Hello, we're live, maybe, I don't know, Firefox, YouTube, on my channel, Chessbot. What? No, I'm just, what? Guy commented in my video, what the hell? I'm just doing, what is it even called though? Obsidian. Who's watching my videos, for God's sake? That's funny as fuck, but who cares? Do we really care? I don't care. Yeah, I'm just using Obsidian Tang. Then this guy asked me.
In Anki, navigate to tool.
Cost. Land in. Probably I sound like that, right? It's like so silent and then so much at the same time. I don't know why would someone even watch this video. Sometimes I'm like amazed. This tells you how far you are from the budget, and this tells you how far you are. Can we move on now? No, I'm live. Oh my god. Never mind, I'm live. Your channel. Live, let's go. I hope I wrote this like software engineering. Yeah, that's right. you better study and not watch me. Why are you even here? Well, let's put some music. I just wanna be your Sigma. The song. No. This is also good. But like we need more. We need Spotify. I hate those. I don't hate Spotify, but I hate how slow Spotify is. It's like immensely slow. Like, what are these guys doing? Look at this. I'll start the day from like where we left tomorrow. So it's like something here. Because this part is like the best part. No. Okay. I have a. Oh my god, there is like a mosquito in my room. Like what is? Tomasz na. Judaimasu. Oh, I'm loving bangers, only bangers. I don't think you want to hear me singing, bro. Okay, let's go. Where is my chat? Chat. Pop up my chat. No. Okay, let's go. Pop up the chat. No. It's so weird that I cannot make it like smaller. Okay, good. Yeah, semantics. So you have an event pool, and then some are getting from an event pool, and then one of them is got, and then it's executed. Then cyclic operator. Yeah. So you have let's see, do you have code forces today or tomorrow? In 3 hours. We have 3 hours before it starts. It's 2 hours of... writers, tourists. Northern or Asia. You have all these competitions. Number one, the execution of state machines, yes. Run to completion, RTC, blah. Event processing, select an event occurrence, collect and enable transitions. Execution of state machine. Yeah, so you first take you're in a stable state, and then you wait for a event, and then you take the event, you run it till completion, and you go to a stable state again. Event processing. So you select an event occurrence, yes. Collect the enable transitions, yes. Depending on the number of enabled transitions, if 0 event is dropped, RTC is completed. If 1 the transition is fired, executed. If you define the conflicting transitions, yes. The intersection of the conflict, the intersection of the sets of states. So you have a state and you have a set of states, yes. It's not empty. Wait, what? So you have states, and you have sets of states, and the intersection between them. No, states that would exit is not empty. So you have states that they would exit, and the intersection they will exit the state. Not different orthogonal regions may fire in the same step. So how is event processing done, right? Yes, how is event processing? 1. Select process. Select event, what am I talking? Event. Enable. So yes, what are enabled transitions from this event? And then after you have that, depending on the number of enabled transitions. Yeah. Resolve the conflicts. Conflicts. How do you write conflicts? Conflicts. What? Conflicts. Meaning conflicts. There's a T. Oh my god, these T's. No. We need to resolve the conflicts, and then depending on the number of enabled transitions, yeah, you can have 0, 1. If it is 0, it doesn't matter because nothing is changing. It's still in a good state. If 1, then you only change, you execute that one, so you only change one state to another. And if you have many things that fire, then you need to resolve what happens to conflict. And understand this: the intersection of set of states they would exit is not empty. It is empty. I know. Selecting a transition to be fired. No, 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 no. I never listened to this one, what? Oh, they changed it. It's not the one. Banger. This is so good. Like, these ones are like sad and funk at the same time, so are amazing good. Banger. If there are several such sets, the non-deterministic choice. So we have an example, let's see how it works. So we have HT transition is triggered by an event E. State configuration, so we have all these transitions, and we have the state right here is S1, 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 2. Yes. E event dispatch. E event dispatch. Yeah. Enable the transitions. So you have T1, T2, T3, T4. So you have oh, so what kind of event is coming in though? What is the event? Okay, enable transitions. Okay, the event came in and it enabled this transitions. So when the event did, then it enabled T1, T2, enable T3, T3, T4. Well, now you have all the possible, well, where is the conflict? T1 conflicts with T2. Why? Because there is an OR thing and it only needs to go to one of them. So there is one conflict. And what is the conflict? Is the same intersection of sets. I see. So these are transitions, and then transitions allow like to have like to go to different states, but the intersection of the states shouldn't be empty, it should be the same state. So this doesn't happen except when you have conflicting, except when you have different orthogonals. What is how does UML resolve the conflicts? Flex. No, I wrote it wrong. Conflicts, yes. How does UML resolve the conflicts? Well, define the conflicting transitions, resolving, choosing from. Well, yes. transition exit state. Transitions resolving, choosing from a conflict, the intersection. But here the intersection is not empty. T1, T4, but T1 wins here, and then you have T2, T4, T2 wins here. And T3, T4, T3 wins here. T1, T3 or T2, T3 are the possible outcomes, yes. The way they... Oh, that is bad. Yeah, that is bad, because it should be empty. This is a conflict. Should be empty, yeah. That's a conflict. Yeah, because it's saying the state, for example, this two, the states they exit is the same, so intersection of those states they exit is the same, so there is a conflict. This is a conflict. No. Oh, I don't have Anki. So even Anki is very slow though. No. Only one state in an or refinement. Good. And you choose what is not in conflict. And then one of them is fired. Anki. Connecting. Okay, nice. Connected to Anki. Oh, I love it so much, this one. Only one state in an or refinement. Yeah, that's true though. So yeah. You have only one state in an or refinement, so. Only one state. Yeah, only one state. Many states. States in each partition, in each diagonal, orthogonal, and then you have substate, state transition. And higher priority. Yeah. What? Close this. Nice. Ornament will be chosen to one an execution firing example state. Well, you first firing example. Well, you are in the state S1. You are here, and you want to fire. So you're firing. Fire.x xs1. Okay, no, you first exit this. So you have xs11, then you fire this t1, then you have xs1, you have t2, then you have et1, et11, e3, et2. Good practices. Advices to state machines. How to model state. Collect the input events and output actions. Start with simple states. What are the different operational nodes? Okay. Refine gradually. Yeah, extend the transitions. Complete. For each state, there is one behavior defined. Unique, yes. But you can just say there is a one-to-one relation, state, behavior. There is a one-to-one relation, state and behavior. And then the two sides are, one side is completeness. It's completed, it has behavior for each one of them. And one side is ambiguity. It's an ambiguity. Completeness. An ambiguity. Ambiguity. Na 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 na. Okay, what? Do you have ready your fuel? Fuel. If you're bored, you go back. If you launch and ignite, you go to a launch stage. Launch. Yeah. It's saying if this event happens, in which state does it go to? So you have this state, and in this state you have all the possible events. That's what the table is. Describe the table. State, and then you have here all events. For each state, you have state, you have all events, and you just need to tell to which state they go. Yes. Yeah, implement. Oh my god. How can you implement state machines? Well, there are two ways to implement them. One is how do you implement a state machine? One is with a switch, table. I don't have anything more to do here. So behavior, refinement, summary, background, good. What is the next one? Interaction diagrams. Interaction. Why is this such like my music is like so? Just forgot that it exists. What is happening here? Maybe I should turn it a bit lower for you. Oh my god, probably no one likes this music either way. Interaction diagrams. Maybe I should turn it lower for you, like, you know. Keep it here. No. Or I don't know how much. This is okay because it's like twice that. It's like just want it to be in the background. It's okay. Interaction diagrams. Modeling scenarios. How they can be used in the software systems, really, finding use cases, presenting typical and alternative traces. Now these guys are like, sometimes like, what are they doing? Okay, first question is, what is a scenario? Okay, what kinds of interaction diagrams are there? You have communication diagrams, I guess, and then you have interaction overview diagram, and you have sequence diagrams. Good. You have timing diagrams. Timing sequence. Well, I also would like to add this picture. What is a scenario? Partial behaviors. How can they be used in software system, refining use cases? Yeah, you need to refine the use cases. Does that sound? I would love to hear that. Maybe I should put this a bit further. It's like too close to my mouth. Maybe this sounds better, I guess. Yeah, you can refine the use cases. Protocols. Defining test cases. Yeah, you can define test cases, good. Uh-huh. Message sequencer, like Yeah, the role of the entity. Yeah. What is the role in your... You have a role is like you have elements. No. I want to see what they said. Like elements have roles. What they do in the system. Relation between timing, messages, and state transitions. Timing diagram. Yeah. Control flow between the different interactions. Oh, that's why it's called interaction overview diagram. Oh, okay. Set of elements. This is the communications, timing, this is interaction overview. Then you have the semantics. No. Why do I... What is this song? I'm just waiting till we get to the good part. I think after this is like the good part, yeah. Yeah. Okay, so system is... And you can extend them. Communication diagram. Communication diagram following a specific simple message call, yes. You can just read the name. Yeah, it's a control flow between different interactions. Timing diagram. Let's see. What are the timing? State is the syntax. That's a bad question. What are the basics? No man, another plate for tonight. My box in my head and my body is a fight. They're not called instances, they're called roles. Connectable element. Bless me, I guess. What is different? In UML. A connectable element represents the elements that can be connected in a structural or behavior relationship. Such as ports or property. Oh. But ports are objects or property. Properties can be connected? What? Everything that can be connected. Haha, hello. I'm just wondering how this music sounds. I think I lowered it down though. Okay. I'm just making flashcards, like nothing. I don't think there's nothing interesting here, but okay. Just making some flashcards because I need to learn all these things. I mean, it's more interesting when I have to code or do things, but it is what it is. Sometimes you have to do the bad stuff, enjoy something, but The music is good. I know, I mean, if you have to study too, then good luck. Yeah, it's so much easier. I just like, the problem is that I just make them and then I can use them like when I'm like walking or something and I'm like bored, I can just learn. Okay, nice. I hope you get like, I don't know, good grades, I guess. Lol, lol, 5th semester. No, I'm at my 3rd semester though. Like, oh, this doesn't make any sense, the argument of everything. 10 people calling me, writing to me, what the hell? Wild cards. The arguments of everything. I mean, yeah. Dot dot dot. Like this. LOL. Life cycle and message types. What? Creation of a message like this guy. Ah, creation message. Okay, this is a reply and then at the same time is a creation message and I'm like, what is the difference between the reply here and a creation message? Okay, this creates the socket. I mean, it goes into the lifeline, creates it. So, what did I ask somewhere? What are the elements, the basic elements of UML? No, a basic element of activity of sequence diagrams. And key. So it creates the vault. Maybe I need to make some space in here. Nice. Oh, it's weird. It's weird. It's... I don't get the UML guys, like... I don't know what they're doing. I don't get them. You can just code something, why do you need to do all of this? They like do 50 times more jobs just to do a simple thing. Like 50 ways to document something and you're like, I only need the code. I can read the code, please. Lost message, found message. Lifecycle and message types. What? Basic elements and then you have like lifecycle. Execution specification, this doesn't make any sense. Deletion message. Oh, this creates and then this deletes it. A socket, so a client creates a socket and then the socket gets some message, found message, and then it gives some message, so it loses a message. And then they had this kind of pipes that doesn't make any sense at all, but they just call it execution specification. Okay. It is what it is, brothers. It is, we move on. We don't ask so many questions here because this guy's never made sense at the first place, but okay. Sorry, more types of things. Lifecycle and message types. Create and delete messages. Yes, I can see that. And then lifecycle and message type. Create and delete messages. Creating and deleting different actors. Yes. Or roles. Execution. Specification shows when is an actor active. Oh. Yeah, when the actor is active, does something or wait for a reply. Or wait, so it shows when the, what, you see how weird it is? It shows when the actor is active, does something, or is waiting for a reply. So even the waiting state is an active state. So when it is not active, when it's like finished, and then why can't you just like finish it here and what? I mean, screen. Hello. Do I have my tablet? Why is it the wrong way? Okay, that's better. What we're studying doesn't make sense UML, but let's go. Who cares? I'm watching chess. I got Gotham chess. Who watches chess? I drew a state machine here, but like, I don't make any sense why they have like this active execution specification, like this part in here. It doesn't make any sense. If you want it says that if it's active and you have a reply, but if you just want to use it, like you can just, why do you need that part? You can just like, this is when you use it, when it's stopped, and this is when it doesn't use anymore. So just to explain, it's active here. That's what it does. I don't know. Probably they have more ideas why you need that. But execution. But and then they call it execution specification. Like what do you mean? But how do I don't understand. How do I ask a question about it? What is an execution specification? Shows when an actor is active. And then they call these actors, and previously they called them roles. Role and actor, where is the difference? Let's see. Is there a difference between a role and actor? What is the diff between role and actor? I mean, yeah, there is a difference actually, because actor is like the actor is a role is like more broad, and actor is for like the more entities like that interact with the system. Yeah, an external entity that interacts with the system. Exactly, and the role is like everything has a role, like every element of can be a role, and then it tells creating or deleting different actors, and so you're. But this can be any element, any connectable element. So only actors are connectable elements. Well, shouldn't you just write creating, deleting connectable elements? And then you say lifeline represents roles. Anki to Obsidian, I think. You can just like Anki to Obsidian. It has it both in Obsidian here. Yeah, Obsidian to Anki. You can search it in GitHub. It has a lot of things, and you can set it up. I just have set it up like this. It has a name, this one, which you just write a flashcard, and it takes this part, and then it takes the answer like this. And pretty nice, because I can do things like 10 times faster than write it on Anki itself. No problem. It's actually pretty nice. It's so nice because you can just write something, you can be like taking notes, and then you can just like, okay, I'm taking some notes, blah, 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 blah. I took my notes, and I'm like, aha, let me ask a question. And you can specify which deck you want it up here, right? You specify the deck you're in, and then you can just like, I'm taking my notes. Okay, let me ask a quick question. What is PDF? What is the CDF and PDF in probability theory? And you can just like add a flashcard and then some answer here, and then it just adds it immediately. It can like help. A lifeline and message. Okay. Execution specification. That's what is an execution? When the actor why actor? Why do they call it actor now? It just pisses me off in every sense. Like lifeline roles in individual interactions. And the interactions are not only between, interactions are between what? Only actors? Interaction? No, interaction not only between actors, it can be inside the system. Interaction between elements of the UML. Between connectable elements actually, not even objects. It's like, you know, when you try to do math but they mess up everything, so it's not precise at all, and it's like, what is this language? I love math more than all these guys put together, because it's such precise, and like I don't have to ask all the time these questions, what do they mean? When a connectable element is active, lost and found messages. Yeah. This is lost and found messages. Not mandatory. I'll never use it. Doesn't make any sense. Not mandatory. Make it simple. Nice. Combined fragments. Operators for combined scenarios may have one or more operands. Each operand may have a guard. May have one or more operands. Combined fragments. They call it fragments. Lost and found messages. Not fragments. Operators for combined scenarios. Combined fragments. Yeah, these are we call it fragments. Oh my god. And then they have operators for combining scenarios. Then this is so a fragment is like a smaller scenario or a part of the scenario. But a part of scenario is also a scenario, right? What? Never mind. Just move on. May have one or more operands. Yes, each operand may have a guard. Operation pending. If the operation is pending, you have this. Else you close. The alt kind of the operator is alternative. This is the alternative operands. These are called operands. This is a combined fragment, all of it. So you have an operator, you have the operands. Yeah, the inputs, you have this one or this one, and then you have a combined fragment, okay, and you have a guard. For choice, I'll choose from its operands, optional, either its operand or an empty trace, loop, with lower and upper bounds. Break, execute use operand instead of a remaining of a interaction. You break. It executes his operand, yes, of the operand, instead of a remaining of the interaction. Detailed semantics will not be this. If they ask me in the task to use this kind of things, I'll be so mad. Negative assert, ignore, consider, okay. Interaction use, supporting decomposition and reusability. So you open a reference. What is a ref? And then you have a semantics. It references another interaction. This is a reference in another sequential diagram. I see, so here your reference is another sequential diagram. Yeah, you have all of these combined fragments. Establish connection. Set. So you have execution. I can read. Okay. Execution, occurrence specification. And then you have. Can I? Okay. Message occurrence specification. You have a message. This is synchronous. It's a synchronous case. And then you have the asynchronous message. Yep. And then you have general or what? General ordering? General ordering. It never even mentioned. We have never even mentioned general ordering. So we create a message, we have a lost message, and we have a general ordering, we have a found message, we have a destruction event. And we have, okay. We have interaction, operator kind. Yes, you have combined fragment, interaction operand, you have two operands. It's an interaction constraint. You have gate. What? This? Gate? What? Okay. Gate, never mentioned. Interaction use and state invariant. State invariant. Yeah, this is another interaction. You send state. This can be very complicated. Like, this can get extremely complicated. Even more complicated than just writing a simple program. Interaction use state invariant. Now this guy's gonna drive me mad. Like, this references another interaction and then a state variant, send state. State invariant, it doesn't change. God help me. Yeah. What does exactly? No one knows. Literally, UML, no one knows what's happening. These guys are like... I love mathematicians, my guys. Like, the math guys just make it clear and everyone understands. Yeah, no one knows. Banger. Oh, this. The semantics defines sets of traces that are either valid, invalid, or inconclusive. The basics of semantics. The semantics defines sets of traces. Okay. Sets of traces. You have traces. Okay. Behavior, but sets of traces are behaviors. Yeah. Look. You have a example, trace of a state, these are traces, series of input output. You have series like what can happen, and then many of them put what can happen, like with a trace you explain what can happen, like what kind of sequence of input outputs can happen, what can the program do, and then you have a behavior, and the behavior tells you always like possible input outputs, like things that can happen, put some of them put together, create a behavior, and that's a set of traces. But the behavior is a set of possible, set of traces. And this is actually the same thing. It is a set of traces, which is behavior, which behavior is valid, invalid, which is inconclusive. Elements of a trace, event occurrences. Elements of a trace, event occurrences, sending or receiving messages, evaluating state intervals. Event occurrence, sending and receiving message, evaluating state invariants. Interaction defines a partial order over the event occurrences. Not each pair has a defined order. Several traces are possible. Evaluating state invariance. State invariance. Na 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 na. State invariance. UML. Oh my god, nice. State invariant UML. It's a runtime constraint applied to a lifeline in a sequence diagram to specify conditions that are always true when a state is in a current state. State invariant in UML is a runtime constraint. Okay, when a comment invariant also evaluates its constraints. Right. At that point you should have that, I guess. State invariant. So in this state nothing should change. Oh, I got a new subscriber, no way. It's a parody. What? It's a parody? It's a parody? Yeah, web users. What? I got a new subscriber? What the hell? Let's go. I don't know. We have state machines. Event occurrences. Yes, elements of a tray sending or receiving a message, awaiting state invariants. Okay, watching it is a right or no. An interaction defines a partial order over the event occurrences. Set of traces. So you have an event that can happen, and you have the behaviors, you have a set of traces, only specific behaviors, that's why you have a partial order. What is the outcome of this? Doesn't tell you what you need to know. Not every element is comparable. Posets and directed acyclic just model relationships that are not all elements can be precisely ranked or compared. What is partial order? What is I think No, no, I should put in na 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 na. What is a partial order? Not every element of a set can be compared. Not every element of the set can be compared. And partial order. Weak partial ordering. We haven't learned this to event occurrences. Because this two can happen at the same time. So you can send X, receive X, send Y, receive Y. Here, send X, send Y, receive X, receive Y. But this for sure happens before this. Partial no problem. After 12 hours reply. Numbering of a message. Yeah, you should be careful. Actors. They call this actors. Monster moved E. Get neighbored. Modeling is sequential and then distributes it to several independent actors, yeah. The meaning of a further element is even more complex. It may depend on Go application, initial and certain plan description of test case, okay. Invalid and inconclusive traces, many different interpretations specify the intention of a model. Communication diagram. Yeah, monster kills Pac-Man. Monster communicates accepts with a field. Name, type, lifeline. Synchronous message. Collide with. Get neighbor, remove am. So it communicates with get neighbor, it says remove am, but it doesn't tell you the order of things happening. It communicates with was hit, a monster was hit by a Pac-Man, the monster die, monster accept, field, collide with Pac-Man, field, collide with Pac-Man, remove field. Description of a single trace, advisable in the case of single-threaded systems. Time diagram, so you have a rocket, engine state, time axis, you have ready, fuel, rocket state, flying and landed. It's off, and if this on, engine if this on, launch, land off, shut down this, yeah. I mean, yeah. You have a gate. Na 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 na. This is interactions. Basic elements. Well, now I need it's been 2 hours and I'm in the same. I'm stuck in the UML interaction diagrams. That's insane. This was actually a hard one. Because they were trying to explain things they don't even know themselves. Geniuses. Yeah, very. Just had a new. Oh, I have structural modeling. this funk is good. Atmospheric funk. Metadata. I can just put this on replay all day. At the end of a lecture, students are expected to be able to recall objectives of structural modeling. Use the UML language to model components. Use the UML language for conceptual and object-oriented modeling. But please. Line item class. Your order dependency account. Dependency change of supply may influence the behavior of a client. no. Admin client uses business logic, mobile client uses business logic. It implements the interface, it uses this interface. No, I don't need a point. This is actually to try this exercises. I try to do this exercise. What else? And I need to eat because I'm not eaten. I want to eat so bad. Well, I'll do the high-level architecture. I'll first cook and then do that. That's cool. So I'll be back in a while. I will be back in a while. I'll just write it on. We'll just, yep, so I'll be back. I just need to write something with my friends, I guess. I'll be back. Okay, I'm back. I'm back. The system can be divided into three main parts: a central server, which consists of components implement central functionalities, an empty MT2 system that contains, and let me put on some music, right? So let's keep going because we don't have time. Na 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 na. Na 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 na. Banger songs, oh my god. Okay, so now the point is how will you implement it? So the system can be divided into three main parts. So you have three components. You have a central server. Institutional. So you have modules of the MT2 server. So you add, change, delete, publication. So you have modules. You have a server itself. So you have a server. It is this server. Oh, you can't even see what I'm doing. I draw a server. So what can we do at the server? We can add, change, delete publications. So we can add, change, delete publications. So I can add a publication. I can change and delete publications. So that's an interface. This ensures that the users can successfully enter publications into the system and that users can make changes to these records. It provides an interface. Provides an interface. Server provides an interface. I mean, at the port, or at the port it provides an interface. Just provides an interface. But how do I... So we have two modules. We have publications, right? So we have two modules. We have a server, and this second module is what? Publications. We have publications, and publications provide. This is a delegation, right? We need a delegation here. Like, can I please pen? Hello pen. Like, why don't you fucking work? Sometimes you are. So yeah, okay, now you work. Nice. So you have a pen, and then you have a delegation here. So you have publications. Yes, and then you have import and export data in the appropriate format. So you have this. You have export, import. And this provides an interface. To export and import. But then you have a data somewhere. So you have a server, you have a data, publications. You have publications, but you have publications. This system. Oh, hello Erin. Hello. Hello again. With the import module you can automatically import publication data. Bro, these guys don't make any sense. But this doesn't make any sense. It doesn't make any sense because you can just... Ah, these people do not make any sense at all. You just do this and you already have the thing. Why do you need this? Like you just have... Here you have add change delete, right? So add change delete, and here you have import. What do they mean? Why do you even have modules? It doesn't make any sense to have modules for that. What is a module? Are we in the same what is a module? It's not. How can it be a module? So you want the data. So you want the data here. Data to provide an interface. And this modules. And you say you have this kind of modules. You have a delegation here. Then you have the system import. Data cleaning. What? So badly written, it's insane. Because the point is, you have you have a system, a server, you have an outside world. I need my one. Guess the chassis, you know. I need this one. I can. No. Like, do you have any questions? If you have just questions, just ask me. If you have any questions, just ask me here in the chat or somewhere, and I can just like answer them more easily. Because I can draw here, like I can show you. No. I don't even know how much you can see with me. Like I'm trying to draw the thing you want it to, like this thing. And this uses this interface, data cleaning one. Only the data corresponding to the MT2T database is entered into the system, right? So this has this kind of delegation. We have this kind of delegation here. This uses data cleaning, and this data cleaning should use import. Uses import. So import gives an interface, and then this accepts the interface. Right, and then it implements those two interfaces, right? This import, and then we have the outside world, like Web of Science. So they have I mean, should I write databases? It's just databases, generally to databases. Just databases, and those databases have an interface. Right? Databases have an interface. Databases, and what they implement is they implement those two interfaces. standard interfaces. Standard interfaces. I can write interface and so on, same thing. So you have standard interface, you have standard interfaces, and this is how it is. This is what you have. And then you have import. I mean, can use the import, or it can use the import data. But the import and export uses add, change, delete. Uses this guy. So now it depends how you want to implement this thing. Because maybe you want to have this thing, like this thing have the edit. This is the edit thing, right? The data, the edit thing, and this is one-to-one immediately here. Or this has an implementation to export import, which is a better interface. And this interface is used in the other subsystems. Yeah, this makes more sense. Okay, wait. I'm still checking the lecture side. Okay, the stuff inside the components are just elements, right? No, are components themselves. Are the modules. Modules are also components. They're the same thing. Like components. Sorry. If I take time to answer, it's just components itself. Yes. No. Those are components. Those are components too. Yeah, this is approximately what it's asking. So if you read one more time, the system are divided in 3 main parts. Yes, I have 3 main parts. I mean, I have the 3 main parts, right? And then it says consist of components that implement central functionality. So a central server has components which implement central functionality. This data is like add, change, delete, and then import, export uses the interface of this to create the import and export to standardize. And this provides an interface. This also add, change, delete provides an interface. And then you have the modules, and you have a system then. And then MT2T system says that contains not only local but also institutional models. So the institutional, so you have the system, and you have like import and data cleaning, and you have the import, which is used for the outside world to import from other databases, which implement those interfaces, standard interfaces. And take this, and then this import provides data, right? So the data cleaning takes this import, it cleans the data and uses the export import to put the data into a database. Or another way to do it is that you have data cleaning, and you have it like this. Another way you can do it is that you have this data cleaning. Like another way to represent the same thing. This is also, I think this is better. You can have like this, right? No, you can have like, it needs an interface, and this provides data cleaning, right? This provides data cleaning. It can be so many ways. So this can provide data cleaning, and then this requires the interface. This requires this interface to import the data to the database. So it takes the data from the outside world. So it takes data from outside. You use the data cleaning like like a component. It uses this so it can clean the data, and then it outputs it to the database. You can also do it like that. Data, okay, the data in the component server does this: add, change, delete publications, right? Because it adds, you have data in here, and then you have this thing right here. It's like the add, change, delete, because those are the elementary operations you can do on data, right? So data provides like an interface how to change the data. And then there's also like a component that uses add, delete, and then encapsulate them into export and import for large amounts of data, right? And then you can provide both interfaces. It provides add, change, delete. Elementary SQL. Classes in different languages. Okay. ML class models, what can do when you generalize classes? Okay, classes are object-oriented, object, a unit of a common storage of data and methods. Yes, a template definition of methods, variables in a particular type of a class. Yeah, a class in modeling languages. UML, a group of model elements. Okay, a class is a group of model elements. So you have elements that have similar structural characteristics, attributes, and associations. Yeah, so you take several elements, and those elements have the same attributes and associations, and you create a class. What do attributes have in UML? Okay, indeed. Class diagram. Yes. Can be used at different levels of abstraction. Yeah, you can have various degree of details in classes. Easy, a class, a concept from a model system. A class, a concept from a model system. Common state, behavior, and constraints of things, objects. A class has objects. Contains objects. Yeah, if you wanna write attribute and you wanna write multiplicity, how many? I also asked the professor for no. The QML syntax summary, like I don't know what kind of syntax I provide. Do they provide to us all the multiplicity so it's more easy for us? I don't know, it's just some of the things. Yeah, he doesn't reply, he never replies. Should I write an email to him? It's like... What? Did he see those? Yeah, he just saw those. He never replies. Does he reply to like overall general channel? Yeah, like I don't get this, guys. Like they tell you, we're gonna provide the syntax, and you don't know which kind of syntax you're gonna be provided with. So it's just like so weird. Generally, this is what happens in university. Bro is writing an essay. This volume. Yeah, I'll probably mail him. But do you know where you can find the UML syntax summary? Because we need it for the exam. I don't know, let's move on. Because we have a lot to do. Yeah, you have attributes and you have a type and you have multiplicity 1 to many, 0 to many, 0 to 1. Interesting. Interesting guy. I'll write an email to him, I guess. UML building types, primitive type, primitive integer, primitive boolean, primitive string, primitive unlimited natural, primitive real. Primitives. I don't know how much of the syntax will it give to us? Will it give us like a lot of syntaxes or like a small part? Like, I don't know. That's nice, that's nice. If it gives us like all the things. Generalization. This is saying you can have multiple inheritance. I mean, I just remember all of them, so either way it doesn't matter. Abstract classes. Do I have a notation of abstract classes? Yeah. I mean, we have it on slides. I know, I've learned most of them. I guess it's not hard. Yeah, on Anki. Yeah, you have it on Anki. I can send them all, I think. After I finish them, I'll just send you all. After I finish them, I'll send you all. This is all of them. I'll just export it to you. After I finish them, I'll export the SE one. So you have SE, I'll just export the SE to you when I finish it, because now I've not finished it yet. Okay, when I finish, I'll give it to you. Okay. I mean, like these flashcards are like more specific to me. Like it's not very general. It's usually what I don't know, right? But if it works for you, it's fine. Expand, redefine. General, specific, then you expand, you redefine, blah 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 blah. Associations. They are called attribute. What are some structural attributes and associations? What are associations? Where did I read associations? Associations. Oh, a group of model elements that have similar structural. And me. A man in a man. So a group of model elements of similar structure and characteristics. That's a class. So have a similar associations, attributes. I mean, stupid dumb question. Yeah, what is the abstract classifier? Good. Expand, redefine. You can do both of them. Good. You're a man. You're a man. And what is association? What does it contain? Oh, there is a definition of association. Abstract classifier. A behavior can be abstract to association. A semantic relationship between instances of certain types. So you have an association, you have a semantic relationship. Yes? Ah, this is just an association. It's always there. It stores the attributes. This is very important here. Because the association stores like the attributes. The way you implement it, it doesn't matter. This is association with this. So there is one consumers, and consumers have many orders, and you see a consumer has many orders. There is a one-to-one of product and order. Attributes assign values to instances. Attributes assign values to instances. Yes, attributes assign values to instances. I will only want to have this one. Like this have some. PC go crazy, meta, data, music. Yeah, best music in the world. You see, you don't need to think about implementation yet, okay? Oh my god, this is too much. A separate attribute does not necessarily have to include for an association. You don't need to think about implementation yet. But okay, I see attributes assign values to instances. Yeah, multiplicity. A customer may have 0 or more orders. Association and the property type order. Yeah, association and attributes assign values to instances. So you have instances, and those attributes assign values to those instances. Makes sense. Yeah, there's a different way of modeling attributes. Yeah, this is wrong. A professor, it has one too many. It has a professor has 0 too many books, and a book belongs to textbook was written by one or many professors. Which terms are identical? What does it mean by term? What is the meaning of term in your mind? So everything. Are these things, are these object classes identical, have different subtypes? Yeah. Instances, instance specification. So you have a person, Don, and you have a person. In UML, there is no such static model element as an object. Exactly. And you have a link. What you call it, a link? An instance of an association is a link. I don't know. And you have constraints. So let us do this one. Or I can just write atmospheric fog. Oh my god, atmospheric funk. Bro, funk. I love this one. These ones are so good, like. This cat. Oh, banger. Yeah, let's try. Okay, let's do this exercise real quick. So you have exercise empty concept model 1. So stores publications. So we draw a component diagram, and this guy stores publications. An example of a publication is a book. A part of a book or a journal article. So we have publications. Alright, so we have publications as a class. How do you exactly draw a class? You just write publications. Nice. So you just have publications. So you have publications. An example of publication is, so you have publications, right? Is a book or a part of a book or a journal article. So you can have a book I have book. Oh yeah, you have an extended, right? Extends. And extend is the generalization. Yeah. You have a generalization, you have book, and you have it's a book. It's part of the book. Or you can say it's made out of books. Parts. This is very bad. Publication is a book or a part of a book. But part of a book is also a book. A journal article. It can be a journal article. So it can also be a journal article. So you have a journal article. So I have oh my god, I'm writing and no one is seeing nothing. Okay, so I have a journal article, right? So the journal article. A book is a non-periodical, but a publication is one or more volumes. Okay, or a journal article. Okay. A publication is a book. An example of a publication is a book, a part of a book, or a journal article. Let's call this part of a book. But a publication in one or more volumes. A book is a non-periodical, but a publication is one or more volumes that form a complete. But a publication is one or more volumes that form a complete. A book is non-periodical, so non-periodical. But a publication is one or more volumes that form a complete. What? A publication is one or more volumes? You can't define something by something. This is a wrong sentence. This is such a bad sentence. This sentence shouldn't be here. But a publication is one or more volumes that form a complete publication. No, a publication is a set of one or more volumes. That's how you say it. This is so wrong in every possible sense. That form a complete publication. These guys are playing that. Okay, but a publication is one or more volumes put together. A journal is a so a publication. Then we have components. Where is I want not the ends. I want aggregation is made out of. Aggregation, composition. Aggregation is different from composition is made out of, and the composition has the black thing. Includes. That's composition. So we need a composition. So right now you have this, here you have a composition. It's composed out of volumes. And this is composed out of volumes. Composed out of one. Publication has one. It belongs, I don't know, to many. It doesn't tell you if it belongs to many publication. It says one or many. So publication is one or many volumes. One or many volumes. A journal is a uniformly edited publication. A uniformly edited publication that appears at regular intervals. A uniformly edited publication that appears at regular intervals. So it has intervals. It has intervals and uniform. as intervals. Conferences may also have publications. Just intervals. I mean, this is not really needed, so I'll just make an X here. It's not really needed in a sense, but you have intervals is needed. You need to specify the intervals. We also have publications. Okay, conferences. Now we're talking about conferences. What? So, conferences. So now we have conferences. We have conferences. So you have conferences, may also have publications. So it's an aggregation of conferences. A conference can exist because it may also have, it can exist for that. So it can have a conference has 0 to many publications, 0 to many publications. Which may be either a journal article or a book part, but not a book. It can be a book part. Well, but it belongs to a book part belongs to a book. But publication has at least. Okay, but publication has, because it doesn't make sense to make it as a book. It doesn't make sense to make it as a part of a book, because when you upload, the thing, you upload it to a completely book system. Right? It's part of the book. This is a part of the book at the first place, and because it's a part of a book, it needs to have the properties of a book, and then it is a part of it, not the whole book. A publication has at least one author, so you have a publication. It has author. So it has the author. The order of authors is important. The first and the last author may play a prominent role. So, to be a it can't exist without an author. So it's a part and it can have a one to many authors. At least one author. The order of authors is important. The first and the last author may play a prominent role. Let's see when the Codeforces starts. Yeah, I have 1 hour and 39 minutes before it starts, right? Yeah, I have 1 hour and 39. Oh, contest is running, what the fuck? Oh, I messed it up. Oh, Codeforces. Well, Windows D, Windows tab. And here I have Genie. I have Firefox. I don't know what can you see, but I'm doing the Codeforces. Firefox, let's see, go to YouTube. Can you see the other things I'm seeing? Go to my channel. Yeah, you can see it. And I have Genie. And then I need to go to Firefox and I had to Codeforces because this thing is running. So, and then we have a contest. Contest is running, I'm late 30 minutes to the contest, I already finished it, oh my god. Constructive problems, let's see. Ooh, Also, Greenland. Oh my god. File new C++. Yeah, Control save A. So you have A. So let's see, what is it? So Greenlandia has been hit by flooding, and now he reconstructs all of his cities. Greenlandia can be described by an N by M matrix. Initially, all his cities are in economic collapse. The government can choose to rebuild certain cities. Additionally, any collapsed city which has at least one vertical neighbor, the government can choose to rebuild certain cities. Additionally, any collapsed city which has at least one vertically neighboring rebuilt city and at least one horizontally neighboring rebuilt city, at least one vertically and at least one horizontally neighboring city can ask for aid from them and become rebuilt without help of a government. More formally, collapsed city positioned IJ can become rebuilt if both of the following conditions are satisfied. At least one received points, or at least, yes. If the city is located on the border of the matrix and has one horizontal and vertical neighbor, then we consider only that city. What? If a city is located on the border of a matrix and has only one horizontally or vertically neighboring city, then we consider only that city. Yes. The government wants to know a minimum number of cities it has to rebuild, such that after some time all the cities can be rebuilt. The only line of each test case contains an M, the size of Greenlandia. For each of the test cases, output so it can be 100 by 100, so 10 to the 3rd is the maximum. Okay, for each test case, output a single integer, the minimum number of cities the government needs to rebuild. So it has a 2 by 2. Ah. So we have let's see. So we have a Cn. So we have Cn. Well, we need int m and we need to Cn nm, right? And then that's m. Oh my god. For what do we need to do? I need to find. So 2 by 2 you need 2, because if 1 you can do nothing, right? And a 5 by 7. So you have a 5 by 7. I mean, can I yeah, and a 5 by 7. So in a 5 by 7, how does the thing look? Well, so you have a 5 by 7. So you have a 5 by 7. I don't know, you have a 5 by 7, so it's... I'm not thinking good right now, right? 1, 2, 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And it says the answer, for that is I only need 7. And for the 2, you only need this. So it says it only needs 7. 1, 2, 3, 4, 5, 6. Well, 1, 2, 3, 4. Oh, this is such a good pattern, yeah? No, you don't even need this. Because you get this, 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 and then it's just all covered. And this 1, 2, 3, 4, 5. We have 5 in here, right? Have so 1, 2, 3, 4, 5 covers a 1, 2, 3, 4, 5, 6. 6 is 5. What? It covers a 6 of 5. But if you have a diagonal, it covers them all, right? If you cover a diagonal, it covers this, this. So if you have a cube, you just have a diagonal to cover it all. And if there's not a cube, well, with the diagonal, well, if there is one element missing here, but yeah, this expands the diagonal. So with 5, so if you have a 5 and 7, yeah, 5 and 7, with 5 you will cover a 5 by 5. So you have 1, 2, 3, 4, 5, 6, 7, and you have 1, 2, 3, 4, 5. So with 5, you will color this thing. With 5, you will color this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's 5 by 5. This is 5 by 5. Oh, is this covered though? Shouldn't be covered. Because this 5 by 7 is just 7. It's the biggest one? So it's just the biggest one. Yeah, it's just the biggest one because of... It's so easy. What? Oh, and then FN 5 273. What? So you are given a tree in one Zelda operation you can do. So beginner's Zelda time limit, okay. So you have a tree in one Zelda operation you can do a follow. Choose two vertices out of the tree. So you can choose U and V. Compress all the vertices on the path from U to V into a vertex. In other words, all the vertices... Oh. Choose the vertices of a tree U and V. Compress all vertices on the path from U to V on the vertex, yes. In other words, all vertices on the path U to V will be erased from the tree and new vertices will be created. Then the vertex as it has, so on the path U to V will have an edge to the vertex W. Yes, determine the minimum number of Zelda operations required for a tree to have only one vertex. A tree is a connected acyclic undirected graph. So yeah, but you just count the number of leaves. From this to this you're gonna have one, and then from all the other. And this is the number of vertices. Yes. A number of vertices. contains n minus uv and ui, or the number of vertices connected by the... I don't know for the moment, I'm just trying to solve this real quick. So ith of next ly contains ui and vi, the number of vertices connected by the ith edge. Ith of the next n minus 1 line, so you have n minus 1 lines, you have 3 lines, and you have... Do you have like a graph in here? It's connected to the given edges form a tree. The first one is 1. First one you just have a... For the first one you just have a... You have 1 is connected to 2. Well, you have 1 is connected to 2. You have 1 is connected to 2, 1 is connected to 3. So 1 is connected to 3, and 3 is connected to 4. 3 is connected to 4. But because the degree of each of 1 is 2, it depends on the degrees. You sum up the degrees. For each degree which is 3, you add 1. And you have 2 which are degree 2. So you have 2 with degree 2. So you have 2 with degree, all the others are gonna have degree 3 or higher. Plus 1. So find all the ones with degree higher, so just find the degrees. So it's a simple hash map. It's just a simple hash map. Copy the input. This is the input, and you have b.cpp. And what do you do? Yes. Yeah, you can just use an array. An array. You can just have a vi, a vector. You can just have a vector. You just have the array, so you can just have a vector array, and then the array is equal to 10. No, have a vector array, but you need to you int n, and you see in n, and you need a vector array, and the size of the array is n. Well, indexing starts from 0, so n plus 1 for simplicity. Plus 1 and all zeros. And then 4 int. Less than n minus 1, I plus plus. What do you do is then you take in the vertices, so you take in, so you have int x and y, x, y, int c in x, y, and then a at x, not at x minus 1, x plus plus and the a at y plus plus. And then the solution is int sum for 0 and for int a in a, for int v in a, if v is greater than 2, is greater than 2, then sum plus equal v minus 2. See out some zero 8 8. It's not even 4, what? You have and then you have x. Did I mess up something? Did I mess up something easy? Yeah, I think I messed up something easy. Why is the sum? Why is that not 4 of them? Only 3 of them. Input. Input looks good. There's nothing wrong with this. Plus plus? How am I adding them up? What? Am I doing something wrong? Why don't I get 1? Well, 1 should be greater, it should be 2. And I should have, by default, it should be 1. By default, it should be 1, that's the thing. Oh, FM5. 199, and then 1 2 3 1 2 3 4 5 6 7 8. So it's from 0 to n minus 1. What? Yeah, this is 1, that's good. And this, how much should this be? Should be 3. Well, it is. Well, if you think about it, 3 has degree 3, so you get 2 for sure. And 3 has degree 3, so you have 3 to 1. So you have 3, you have 1. So you have 3 to 1, you have 3 to 5. So you have 3 to 2. 3 to 2, 5 to 6. 5 to 6, 6 to 7. 6 to 7. 7 to 8. 7 to 9. 7 to 9 plus 1, so you have 3. And 6 to 4. So you have 1, this is a general one, right? And then you have 1, 2, so you have 4. So you have 4 and it's 3. Should be 4 though. 6 to 4. And 1, 2, 3, 4. You need 4 paths. This has degree 3. This is degree 3. Let me see I. Print V. A. Print A. No. Six. What? So you have 9 and you have 3, 1. Well, 1 should have 2. What? This is even worse. Yeah. And it says what? What? You take L? You create a vector right there. Three has 2, 1 has 2. This is completely wrong. Why does... No. Why does it completely have a... Like, what? This is not right. And why is it... Why is it so small? Why is 0, 0 to 1? It would be n plus 1. N is 4. N is 4. What if I do this? What's that? Why is this not 4? What? N plus 2? Why is this so wrong? What? And then this is so wrong too. We'll do this ax plus plus. This is so funny. This n is 2? How is n 2? Are we in the same input? Control save maybe? Ah, maybe I didn't save an input. Oh my god. I should be careful. Ah, well, I changed my setup. Yeah. I forgot to save the input. And what was the solution? 1422. And it is 4. How can it be shorter? Because you have 3 to 1, you have 3 to 1, you have 3 to 5, you have 3 to 2, 3 to 2, 3 to 2, you have 5 to 6, you have 6 to 7, you have 7 to 8, you have 7 to 9, and you have 6 to 4. What? Yes, and this is 4. We're gonna make this on 3. How gonna make this on 3? What? That's how many pals you need. What do you mean? No, it is what? It is what? How are you gonna make this with 3? And this maybe? There's no way you can make this with 3. You're saying 3. How many paths you need? What the? This is just one vertex. Yeah, one vertex, and then this one vertex. Oh. So this to get connected. So my solution is that thing divided by 2, round it up. So I see, I have 1 connected to 2, 2 connected to 3, 1 connected to 3 I mean, and then I have 1 to 4, 4 to 5, 4 to 5, 2 to 6. Here you just need 2. But you see, only 1 has higher degree and you always need 1. Yeah, it is a sum sorted from 0. sum divided by 2 ceiling. How to take the ceiling on C++. So you just take the ceiling of sum over 2 and you add 1. What? This is so wrong. 1 by 1. Well, the sum is 1 divided by 2, so it is 1 plus 1 is 2. .0, and then this is right. Ta na 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 na. Ba na 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 na. Larger subsequence. I need some. I need lights. I need some water. Instead of the largest subsequence. The largest subsequence. It's just. Isn't that the largest subsequence? Just. So we need file new and see. So given is a string s of length n, so we have a string s and it has length n. In one operation you can select the lexicographically largest subsequence of string s and a cyclic shift it to the right. Okay, given s of length n, so you have s and it has a length n. In one operation you can select the lexicographically largest by cyclic shifting string. And cyclic shifted to the right. A string A is lexicographically smaller than a string B if and only if one of the following holds. What? Subsequent? What? Oh my god. I don't understand the question though. One, two, three, four. That's pretty interesting though. Oh. I have no idea how to do this one. If it's impossible, or -1 if it's impossible. I don't know, maybe it depends on how many are besides them. So for example, you have Y, B, C, A. Can you sort this one? But ZBC is the biggest one. No. Yeah, you have Z, and then you have Y. And then you have C. What do you mean by a subsequence? What is a subsequence of a tree? What? Ah, you need to understand what a subsequence is. I see, I understand now. So subsequence is like A, Y, and then how do you choose Y? Well, then you say B or C. No. I don't have no idea about this one. I'm pretty sad because I have no idea about this one at all. This is it should be easy, but actually I didn't understand subsequences in strings that well, so it's not very easy for me to understand this part. That's why. That's where I think the problem is. Well, in this one they say you need 0, you need 6, this one you need 0 because it's ordered. Maybe you start from the small ones. Oh yeah, I think I know how to do it though. I'll just lower the music a bit down because it's too much. I think I know how to do the thing because this cannot happen. Why can this not happen? Well, you can change B with C, it's the next one. Ah, it means that if you change those that are 2, then every 2 subsequent should be great. I actually do not know. Well, it's pretty interesting, not gonna lie, because it should be easy in a sense. I mean, I have 44 minutes, but like, I have no idea. I'm just doing these exercises for fun. And then, can you exchange them every time? But why doesn't this work? Well, this works because you can just exchange, and after exchange, it's sorted. Oh, maybe the numbers should be greater. Well, first is Z and C, and you can sort Z and C, right? You can sort everything. So you get, let's suppose you have Z, B, C, A, and then you sort Z and C first. You get C, B, Z, A. And then you can sort one more time. So you get A, B, C, Z, and it's sorted. So, in a sense, for each each substring you can sort one. So in a sense, for each substring you can sort one. So this, how many substrings it has? It has only one, right? And this, how many? Oh, it can be repeating. Well, how many substrings it has? Well, it has many substrings, right? Oh. How many substrings can this one have? Well, this one can have, it is 15. So it can have from 2 to 14. Right? Or how many different letters does it have? It has... Yeah, but I think it matters less letters. So if you think about it as 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. No, it has many. This doesn't correlate at all. But I think I got the point there. Because it makes sense if you do the... So I zoom in. Yeah, it just makes sense. Because like you can, so with 3 I can change one, because what sorted bad in here? What are like the ones that are sorted bad? Where Z is bad, A, B, C, and A is bad, and you have 2 sorting options, so it can be sorted. And then how many things are bad here? So you have C is bad, so you have 1 bad. You have 1 bad. How many are bad? You have this bad. Maybe if I put numbers, how many? Okay, C, and then Z, D, N is after E, and M. So you just think. So this sorted is C, Z, Z. C is not sorted is D, C, C, D, D, E, 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 and M, because it's after, right? And M, I, G. So this, there is, yeah. So there is E and C is wrong. So there is 2 wrong, and then N is wrong. So you have 1, 2, 3 which are wrong, 4 wrong, 5, 6 IG. Let me see something. Alphabet. I and G. So I and G are both wrong. Yes, I and G are wrong. So what is wrong in here is Z is 1 wrong. Then you have N is 2 wrong. 5, so it's 1, 1, 2, 1, 1, 2. You're supposing with one go you can fix every letter. Then it's very hard to code. It's not like an easy solution to code, I'm thinking. It's probably there's an easier way. Well, you can say how many wrong are like this, right? Well, Z, and then so there's 1, 2, 3, 4, 5, 6, 7, 8, 9. No, I have no idea about this one. I would love to see the solution. I don't know, I don't get this one. Like, is it like a dynamic? It's like dynamic programming, maybe? I don't think so. Is it like, do I need to calculate all those operations and do them one by one? Then that's like hard. 10 to the 4. It's 2 to the 5 times 10 to the 4. So it's like 1 second, it should be really quick. It's like 2 times 10 to the 9. It's larger than 1 second, which implies that you just need a simple solution, you just need a simple answer. It's probably just a way to calculate it, which I have no idea about. It's just making me a bit angry though. Actually, it's making me very angry. Because, what, like, what? Like, how do you solve, there's probably just an easy way to solve it. And I'm like pretty dumb right now. So I think many people would have solved it, yeah. Not to submit, like, standings, probably like, yeah, many people solved it, I think. No, C, haven't many people solved C? That's interesting. Oh, I mean, oh no, not my standings. Just status, I think. I don't know this website, I'm just a noob at this. Oh. Problems. 3,000 people have done this. Well, yeah, you can think like this. No, but you can't do that because you don't know which one is the next one. Maybe Z is the next one. Yeah, because you don't know. So you have Z here, so all of these are wrong, so you need to change. There is probably such an easy way to do this, and I'm not able to find it. I don't like this. I don't like that this happens. Like when you have an easy solution, you cannot find it. I hate it. So this is just right. It's a linear go. It's a linear thing. It says 2 times to 5, 10 to a 4. It's just 10 to the 9. So the only way you can do it is you do it linearly. You need a linear search. It's just not linear, but just you need one time to go through all of these. You need to go like with a pointer from here to here. Then you can't read the whole string. You just should take the characters one by one. You should take the characters one by one, so I have no idea. Please help. How do you take the characters one by one though? Like you need to take these characters one by one. No, I take the characters, but how do you? Why it looks so complicated, but it's probably the solution is very easy. And my idea is probably wrong because you have one option here you can do, but it's not necessarily that you could have the right thing. Maybe if I think when it cannot happen, more easy. And it also asks how many moves you need. I mean, I'll just. I'll just be back. I'll just Windows D tab, and then I just need the. Oh, where's the OBS though? Yeah, I just need the OBS. What is the OBS doing? Am I even recording? Who knows? Hello? Yeah, I'm live. Well, I have no idea. So I'll be back and I'll just be back and I'll just go to the bathroom real quick. I think I came with the idea that I took each one of them. I think I took each one of the point is that with a whole sequence you can probably get C here. And why doesn't this work? Generally. I know why this specific case doesn't work, because A is in the middle. I have no idea. Oh, 23 minutes, I'm so sad. No, I'm sad. Think what? I don't understand. I don't know. I don't know this one. Why? I think like you this rotation. I've never seen this kind of stuff since I cyclist shift the string. I don't know. Oh, score. So many people are solving C. Oh, I don't know how to solve C. I have no idea. And we can go to D. So many people solve. Well, when doesn't it work for this case? When doesn't it work for this case? You have Z, B, C, A. Well, if I put C, B, Z, A, what will happen? Put A, Z. So you want to sort it. No idea. No particular idea at all. So C, Z, D, D, and well, you can put C up front. I don't know. How many things are wrong in here or something like that? I don't know. I would really love to look at the top solutions right now and just see what they've done. Because I'm stuck for 1 hour at this one, so I just should move on. Well, do D. For an array A, define the cost. Okay. Max. What? Max is the smallest non-negative integer such that x does not occur among. I see. So you do all the cyclic shifts in here. Maximum cost of all the cyclic shifts. Find the maximum cost. There's no one in the array. Ten to the 6 times 10 to 2 seconds. Because 10 to the 5 times 10 to the 6 is like 10 to the... It's still linear, I think. The second's like 10 to the 7, 10 to the 13. It's 10 to the 11. It's pretty close. So linear thing, it's good. N square is not good, and I think also n log n is good. Maximum cost. Isn't max 6 in here? Isn't this 5, 4, 3, 2, 1, 0? Yeah, it is. 5 plus 4 plus 3 plus 2 plus 1 plus 0. No, it's 5. And for 5 it's just 0. So it's a 0, 0, 0, 0. So what you do is you take 0, 1, 2, 3, 4, 5. From 0 you take 1, so you take 1, plus 2, plus 3, plus 4, plus 5, plus 6. Which is 6, 10, plus 15. It's 15. Well, the best cycle, you only have one of the best cyclic shifts. Is the normal one, is the best shift. And it is from I to N. Such that X does not occur among B1 to Bm, yes. As small as X. As an integer, right? A non-negative integer is an integer. So if you just have 0, 0 which is... this is just 1. This is 2, 3, 4, 5, 6. And this is 10, 15. Plus 15, 21. And solution is 15. What? So you have a 2. So you have 0, 0, 0, 0, 3, 3, 3, 6. This is 15. Yes. It's 5. It is 1 plus 1 plus 3, which is 5. Yeah, because for this one you have 1, 1, 3, 5. But if you just have 0, if you just have 0, 1, 2, or 0 is 1, and then you have 0, 1, just 2, 0, 1, 2, which is just 3. You get 6, which is larger. And why is that not working? Ah, it's just a cyclic shift. Okay, brother. This is a computational task. Or there is an easy way to do it. Well, I don't have time to code it now, but... I think this can be a computational task, right? Because you're shifting them psychically. For I can't even solve C. A maximum cyclic shift. No idea. 4 minutes. How do I compose the cyclic shift? I don't know how I would compute the cyclic shift though. Like, I know how to compute a cycle of shit, but like, I don't know how to calculate it more easily, because it's n squared, you can't just brute force it. Can you just compute it? You have n shifts. So yeah, cannot be n squared though. So each one takes n squared. The computation is n. Maybe it works just to compute it, but I don't know exactly how I calculate. So for each one you will have... So for all of them is 10 to the 6. But you can just have one which is like 10 to the 6. Which is a long one. I don't know how you would compute if you have one which is like 10 to the 6. But how would you compute one? It doesn't work. You should do something else. And then how many times you shift, right? How do you know how to shift? How do you know that you need to shift 3 in here? I think you need to calculate it either way, there's not... Maybe it's just a brute force calculation. Probably. But it doesn't work, the brute force doesn't work, because you have 10 to the 6, and it takes... n... And it takes, so n rotations, and then for each one you need to go through the whole array to compute the... It's n squared. But n squared is 10 to the 12th. And then you have 10 to the 12 times 10 to the 5, which is 10 to the 17, which I think it's over because 10 to the 6 is 2 seconds. Or maybe it is brute force. Let's see. I mean, I'm not going to submit anything, so let's see at the standings. $4,000 people did this. I don't know. Just a second. I just want to see contests, standings generally. Can I just look at the big standings? What do I see? It just died. It just died. Contest just died. Yeah, but I wanna know, does he have a solution? Sell the answer, solve it. No, 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 no. Can I just... Yeah, nice. There's a maximum, nice. Same. Same. What? He literally brute forced it. What? It's sorted. It's like a function, I guess. A multiset. But I am wrong. I can do linear searches as many as I want. Can't do n squared, but n is good. I can do several n's. they're like doing announcements now. I don't know how does this work. So they are system testing it. Oh well. Now stand-ins they all change. Doing system testing. So they're checking at the end everything. Interesting. Who's last? So they're just testing it. I'll be back in a while. I'll wait for a solution, then they come out. Or I'll just be back and doing other things till this finishes. I'll just learn. I need to learn software engineering, so I'll just be back in like 5 minutes. Wait. No, I was just like I doing some exercises in Codeforces, I guess. I didn't even saw you here. No. I mean, yeah, I've done a lot of things before university. Like I've done like more projects, not like real science programming, you know. I've done like more like pure programming. I was just looking at like Codeforces. So I was like, oh, like you can do like computer programming things in here. I was looking, I did like, we had like a contest right now. So this is just an easy one. Like, the first two ones were pretty easy, and then this one I couldn't make it for some reason. Yeah, but it wasn't hard. I probably messed something up I didn't understand about C. I'll do them later. But right now I'll just like... What is this playlist? I don't know. The playlist is just... atmospheric funk, I guess. With like a cat in the background. It's so funny. Yeah, I'll need to study this. I just did that for fun. I did some Codeforces exercises for fun. Empty concept model. Oh, so what were we learning here? Yeah, I was doing a class diagram. Oh wait, you can't even see it. I was just doing a class diagram. Yeah. It's like you have a book. Yeah, the publication has at least one author. The author of the author is important at first. Also, well, I don't know how you would represent this, so would you say first author, second author? So you would have an array of authors. Oh, this is like implementation details. So you would really... A communication may cite an... What? A communication may cite another communication. Maybe they wanted to say a publication. A publication may cite... This is like badly translated, it looks. A publication may cite another publication. So you have a publication to itself. And how would I do this? It's just a connection to itself. Cite. So you just cite another publication. That's how you draw it. It's just a relation. It's just an association, I mean. It associates, yeah. Yeah, and you can write something. And I just wrote cites in here. Cites another publication. And what you have next is attributed to the institution in which they work. Oh, so we have one more about authors. So here we need like institutions, right? And so institute, and they can work in many institutions, so they're just associated with each other. Author can have one, too many, or zero institutions. May be attributed, so you can have 0 to many institutions, and an institution can have 0. An institution, I don't know, can have one author, I guess. No, institution can have many authors. You can have 0 to many authors. blah blah blah. Then instances, instance specification. Then UML there is no such a yes. Concept 2, there is no instance, there is also only a class. For example, a journal article with one author. Okay, draw example models to understand the model. Okay. Instances, instance specification. This is just instances. Draw a journal article with one author. So you have a journal article with one, what? A journal article with one author? Yeah, you would just have a publication. Journal article, and you will say a journal Clavis journal, and you say journal article. This is an instance. And you would say it has one author. It has the author Clavis, which is an author. A conference publication with two authors, so you can have you can have like a publication. You have a publication, right? This is an instance. Yeah, it's just a book whose author has two jobs. You have author and you have a jobs listed here. Yes. You just have instances working together. So the point is that if, for example, the second one, a conference publication, you would have like a conference, for example, Clavis conference, I don't know my name, and then conference, right? You define it as a conference, and then you would have the same diagrams, for example, and then if you had a book with many authors, you have like a book, you have a book, which is a book, and it would have many authors, author 2, author 3, and so on. And a book whose author has two jobs, and an author, and then this guy has two jobs. And now I need to give the constraints. How do you write constraints? I mean, I've been for like 5 hours, but I've not done a lot, so let's go. Constraints. Additional constraints that the valid models must fulfill. Many different elements may get them. Class attribute. Yeah, notation between the curly brace and a separate. What is the notation of constraints? Yes. And this is a comment. You can have it in a separate comment. And what else can you have? You have constraints. Yeah. So what are the other elements? What are the other elements? Data type. Then you have enumeration. Its instances differ in their values only. Its instances differ in their values only, yes. What are the ways to represent an association? The first way is with attribute to classes, and then the second one is just association class. Can multiple associations can be modeled? Can multiple associations yes. Association class, okay, navigability and associations. How who owns the association? Then you should have who owns the association. It's important, composition and aggregation. Do I have it here? What is the notation for composition and okay. So you have these, and then the point is that, oh my god, I hate these songs. I don't hate it, but like I need this. Dun 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 dun. So what is the notation of aggregation? Yes, what is the difference? What is the diff between the aggregation and composition? In aggregation, so the point of the aggregation is that in the aggregation you can So the point of the aggregation is that in the aggregation, what you can do in the aggregation is that you can put things together in the aggregate. Like, what am I saying? The point is that you have the wall can be of both rooms. It doesn't belong to the thing, okay? It can exist without it. Aggregation. The instance can belong to more than one grouping. Example, wall belongs to many rooms. Composition, the instance belongs only to that group. The instance is very important to say the instance here. It's very important to say the instances. In composition, the instance belongs only to that group. Yes, it only belongs to that group. Example. Panel instance
жизнь была очень счастливой. Но теперь пришло время сказке подойти к концу.
space. I mean, I can touch it, but I can't feel it inside.
From this presentation onwards, we're starting with a new chapter that is nested quantifiers, and in this particular presentation, I will introduce you to the concept
Wait, can you hear me now? I don't know because I just removed my camera. Oops. Oh yes. Let's see. Can I open this thing? Oh, okay. Oh, what is happening here? Hello. Okay, now you can hear me. Every day, every hour of my day, I guess. Let me take this thing. Maybe this thing is like so much better. Oh, I don't know what you can see. It's actually very good in every field because you're like logically thinking. Yeah, exactly. You're like logically developing things. Well, you know what this exercise does? Right, I have mine. If you this is not that hard if you just like look at it. So what it's saying is that you have like a string S, so you have A, B, C, D, I, and a string S, and you're saying that you have a subsequence, and the largest subsequence, what the largest subsequence is that like if you have A, B, C, D, E, F, G, and the largest subsequence is if A is a prefix of B, but A is not equal to B. An A is smaller. So if this is A, string A, this is B, for example, because A is like a prefix, it comes before B, is a prefix of B, this implies that A is smaller. I speak Albanian. Yeah, I'm from Kosovo, I think. Yeah, I told you, I think, right now, I don't remember. From Kosovo. So this is like, if you want to explain it, like it's pretty easy. Like this is like smaller, it's like the smaller subset, and this is like the big one. And this is smaller because it's a prefix of it. But this is not necessarily smaller. And then when it says the first position A and B differ, the string A has a letter that appears earlier in the alphabet than the corresponding letter in B. What it means, for example, if you have A, B, C, D, Z, for example, and then some more letters, this is this is smaller, this substring is, larger, this is larger and this is smaller because C is smaller than Z. These are all the same, but C is smaller than Z. I have like a tablet in here. I'm drawing in my tablet. Like I have a picture from my tablet. I just screencast my tablet. And then you just have... And I just screencast with like screen... Like it has like, I found this application on GitHub. I don't know. Yeah, Codeforce is very nice with tasks because you have like this masters, they're like extremely good at making exercises because they are extremely good. So, and then you have this kind of subset. And then the point is that in the first position in B, the string A letter that appears earlier in the alphabet, then the corresponding letter in B. So if it is a prefix, then it is smaller. And then what the solution I think is that this kind of cyclic shift that's happening, and then you're doing the cyclic shift, it explains here how to do it. It kind of orders, it sorts it, and you just need to check if that sorting is right, if it sorts it correctly. Because, and then I don't know exactly how it sorts. So for example, if you have this one, the lexicograph largest subsequence is ZKA as ZCA, and this becomes ABZC. Yeah, because it's like the largest one. But why? I don't understand why. Yeah, Z is a prefix, it's a lot larger than one, so that's why. I just do Codeforces, and I'm used to doing Codeforces for a long time. I don't do code. I've done some LeetCode, but not really. Like I've done my Codeforces so much more. I'm still bad at it though, because I do more projects. I do more than like competitive programming or this kind of things. I do projects more. I don't know. I like doing things. This is also cool though. But like I really don't know how to solve this one. Like it took me so more, like it's been 2 hours, I don't really know how to solve because I'm not good at like substrings and this. I'm good at like at graph theory and those kind of things. And with like this substrings and subsequence and larger subsequence, I'm like pretty bad. But I think the idea is that this kind of this kind of cyclic shift, it sorts the array, and then you just need to do it in a sense and see if it sorts it. If it, and then you just can calculate this number real quick. But that's the problem. I don't even know how to do all of this, like how to find the subscripts and so on. But yeah, it reverses the thing. That's what I'm saying. The largest subsequence. So that's the idea, I think, because let's suppose this was the largest subsequence and this is gonna get reversed. Z is gonna be here, A is gonna be here, it's gonna get reversed. So let's see, what is the biggest subsequence here? Well, the biggest subsequence is... I mean... Should it... What is the biggest subsequence here? Like that's my question, I don't exactly know what the largest subsequence is. So I'm just thinking, what is the largest subsequence here? Well, it's Z for sure will be in it. But the next one is the biggest next one. Because here, for example, it was Z and then C was the biggest next one. But then you could have A too. But like even what is this? I don't understand. Can't like a whole string be a subsequence of it? What do you exactly mean by a subsequence? It's like by deleting 0 or more elements, so the string itself is a substring, so this string itself is a substring of like itself, but is it not the largest? Why is it all not the largest though? Why it is not the largest? Ah, because of this property. And the next one. So you're like trying to find, okay, Z, and then the next biggest one. What is the next biggest one? Well, the next biggest one is, yeah, I know, I don't know the alphabet. Imagine having to search the alphabet. Okay, Z, and then what is next? It is MN, I think. Z, yeah, MN is next. Or not, yeah, MN should be next. Because you have, because ing is, where are ing? Ing are somewhere here, yes. So you have ing in the beginning and M and N are the next ones. And E, where is E in the beginning too? D in the beginning, so M is like, so the order for us here is like, I'll just write it here, is like Z, and then we have M, we have N, we have G, IG or GI, I think it's the other, yeah, it's IG. It's IG, and then we have DC, and then EDC. So then you start with Z, and then Z is the, like the biggest one, and then the next one is like G. No, it's M. So it's like Z, M, and then you have, next one is I, right? Or no, it's G actually, because G was, no, it's I. Next one is I, so it's Z, it's like Z, I, and then we have G, S, and then EC. EC, so it's like this thing. Yeah. So that's like the biggest substring, and this one is gonna get reversed. So let me just just, I don't know, go here real quick. Can I? Yeah, I can just do this. So if you look at that, you have this code, right? And what's happened is that Z was the biggest one, so it's gonna get the reverse. So you're gonna get like, so you have Z. So instead of Z, you're gonna get the C. So here you're gonna get the C, because here the C is, so the word you have is like Z. I don't know what it means, but you're gonna get Z, and then you're gonna get E in here. Then you're gonna get G, I, and that's good because you can see these are in decrease. If you look at their like say graphical order, this are like decreasing. Like Z is the biggest one, C is the smallest one, and because of the rotation you do, because what you're gonna do, you're gonna rotate this, and when you rotate this, you're gonna rotate this, and then what happens when you rotate is that you get this, and then you get a C in the beginning. Oh, a C. I don't like auto completion. And you get a C, and then you get then what is the next biggest one? This is gonna be the next biggest one. So you're gonna have C, and then E is gonna become the next. So this is gonna be like the next biggest subsequence, biggest subsequence is gonna be the next one. And then this is gonna get rotated, so you're gonna get E, Z, Z, M, I, G. And then so on. Then you're gonna get G, you're gonna get shifted by 1, so rotated by 1. Ah, this is E in here. No, it gets shifted by 1. Oh, but it just... Oh yeah, this is gonna become E in here. Because this is gonna be the next one, so E will come to the beginning, it will be shifted to here in the beginning. Because like now it's separated, this is like the biggest part, so it's gonna become here. So I prefer code forces, yeah. And then you're gonna have some here, and then same thing, you're just gonna get reversed. And then G is gonna come here, then I am, and Z. So you're gonna get reversed. I like to write it in my description. Because of the property, because of the property of largest subsequence, properties of the shift will, the cyclic shift, the consequence after the other, how do you say the consequence? No, after the other, the cyclic shifts one after the other will only work, will reverse that largest subsequence, right? It will reverse that largest subsequence. So this is an example, and then the largest subsequence was, so I'm gonna get C, E, G, I, M, Z. So at the end you're just gonna get so the result. The result is just going to be C, C, D, D, E, N, E, 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 G, I, M, Z. And something I did wrong in here, because this N and M, well, which is M is bigger, right? We know this. M is... Ah, that's the problem. I did a mistake in here. M is smaller than N. That's why. So you have this N in here. So you're gonna get this N too. So there's gonna be Z and M. Because N is... MN. Yeah, that's why. It's a different way, the keyboard. That's why. Oh my god, this MN is the other way around. N is larger in a sense. So this one works, and then you're gonna get Z and Z and then you're gonna get Z and yes, so it's gonna reverse. So you just need to check that the larger substring when it reverses, you need to check that when you reverse the larger subsequence, so you just need to check that when you reverse the larger subsequence, let me just tell it, Discord. So you only let me just, never mind, I sold it. Never mind, I sold it. Oh, what? Oh, Discord is so weird. Like, please work. Okay, nice. And then, oh no. So the result is gonna be this. So you're gonna C, E, G, I, and Z. So we get E, G, I, which is sorted. Which is sorted. Therefore, what we do find then else you just return 0. Else you just return the return the number of operations are the size of the biggest. 1, 2, 3, 4, 5, 6, 7. Yeah, but you need 6 because you have 6 shifts. Then the number of steps needed is the size of the largest subsequence minus 1. You interchange two elements. Changing element and with itself. So this is the code we need to write. Yeah, this is what you write. To solve this, I just wrote the description. Maybe it's more easy when people come to read my solution. So yeah, the idea is that how do you do this? How do you find the largest subsequence? Well, you can do a linear search. So the problem it's 1 second, right? So this is 10 to the 4, this is 2 times 10 to the 5, so it's like around 2 times 10 to the 9. Yeah, it's 2 times 10 to the 9. So we can do O of n. So we have n times t is equal to 10, 2 times 10 to the power of 9, to the power of 9, times 10 to the power of 9, which implies, or we can do O of n. We can do like O of n. So now how do we do an O of n? Is that first? Yeah, no problem. First we can go through a thing and we can find the biggest element. And then after that we find the next biggest element. Yeah, or you can use a multiset. Or what the idea is. So the idea is that we assign for each one of them. We assign for each one of them the index from 0, 1, 2, to n. So you have the index n minus 1. So you have an index for each one of them, right? So you have this index, and the point is you sort them. So you sort, then you sort, then you sort, then you sort. So you sort them. So it's just going to be sort of maximum. And we take it until we reach. Or you can use a queue. Why do they use a queue? I don't know. You can just sort them and then find how do you find the largest subsequence? Yeah, you can just sort them like this, and then you found the largest subsequence in a sense till you hit n minus 1. And that's the largest subsequence. Yeah, but no, that's not a good idea. No, sorting is not a good idea, so how do you find so how would I find the larger subsequence? Oh, it's because sorting is not a good idea, right? It breaks the order. So what you do is that you need to find the largest subsequence. How do you find it? You first find Z, but I find the biggest one. Or I can use a queue. You can have, for example... Yeah, you can use a queue. You can have... Okay, so the point is... We use a queue or a DQ, I don't know. So you put D in the queue. So you have like a queue. How would you write the queue? And then you would have a... I don't know. You have a queue, so... A point is you have a D, so you put... In a sense you put like, okay, so I have a queue, so I'm working with this. And the way it works, the queue. In the far, so you put C and then you put Z, put D. So you put C and then you put okay, and then it's so C, and then you put Z. You remove C and you put Z, and then you put nothing. The Z is greater. And you would put D. So you put Z. Remove C. Nothing happens with D. So nothing happens with D, and then you have D again, nothing happens, and then until we reach N, or no, not really, right? Or you can start from the end. Because the end is always gonna be in, so you start from the end. And start from the end of the string. So we put C, we put E, because E is larger than C, right? E is larger than C. Yeah, E is larger than C. So we put E, and then G is larger than E, so we put C, E, G, then we put C, E, G, I, M, and C, E, G, I, M, and when we don't put E because E is like small, and then we put I, and we put the N, we put N, and then we put... And then what is the biggest one? Well, it is... And then at the end we end up with C. no C because it's smaller than Z. So we make a Q for this, right? You don't even need a Q, you can just have a vector. You don't even need it, you just use a vector. And you found the largest substring. And then remember that we save the index. We save the index of save the index of the element. So we also save the index of the element. So we start with like, so it's like 0, 0, 1, 2, dot 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 dot. It's like n minus 1. And we use the vector start from a string. And this is like, so we also have a position, so string now we reverse have C and position of C, E and pos E. And we have pairs of char and position. We just have to reverse the position and check if, and then reverse the position. We insert to the array, so we insert to the array back using the reverse positions. Reverse positions, and we have it. That's all you need. So we just have positions. Position of C. So this is position of C, and this is position of N. And this is gonna be position of N. Right, we insert the array back using the reverse positions. The reverse positions. So string back to the insert back to the string using the reverse positions. Insert back to the string using reverse positions. Yep. And you have it. and we check. Check if it is sorted. So this is the description. So how do we do it? So we take, so we have scene. So we have int n. I'm gonna scene n. Oopa. Can I? And yes. And then int. You can use characters if you want, so right? No, I can just use a string. Int s, and I can just cin s, cin s. And then what I can do is that I can, for each string, so what I can do is that now I need to find the larger subsequence, right? So the way I find it is that I create a vector largest subsequence, or largest subset, just vectors of char. So it's just vectors of C, and this is char. So I just have vectors of char, and then it is, I don't know, we can just push back because I don't know a size, and then for int I equals to n, to n minus 1, right, because that's the first index. I less greater than 0 or equal to 0, and then I minus minus, and then we have we just push a first character. So we push a first character, so dot push back. So I need to push back. I push back, and I have s at n. This s at n minus 1. And then I have if s at I, if s at I, and then it starts from n minus 2, if s at I is larger, because you're comparing characters, so if s at I is larger than s at then at size minus 1. So it's greater than that size, then I just, this largest subset is such, we move on. So it's greater than the size at minus 1, so it's greater than the last element. We just largest subset that push back. So you push back, and what do you push back? You push back s at I, and I should have print v, and I should print the largest subset, and I should have let me have the input. And I should have oh. Oh, it is string. Ah. Not one. And then we have FM5, and let's see how it looks. B. Only B. 1 3. Where is 1 3 from? Just printed the largest subset. This B is BC. A, and then it's, well, it's the largest subsequence here. Well, C is just C. Largest subsequence is just C for the first one. And I get a B. I get a B. Let's store the characters. Yeah. No. It's B11B1. Just. Because maybe it's asset N, but well, that will segmentation fall, wouldn't it? What? 1. And then there is nothing. What is this print? What's happening here? Push back. It's N minus 1 for sure. I can do just add that size. That size. It's not painting characters. Should taking N and should be 5, and it should take S. Let me see out S real quick. S is 1. Because I didn't save a fucking input. Oh my god, now I'm mad. Nice. Okay, nice. Isn't nice? I didn't save the input, that's why it wasn't working. One more time? Okay, just I forgot to save the input. And this is what I get. I get C, I get BC. Let's see, so for the first one is C. Then it's BC. Good. Oh, what BC for the second one? The second one is CB. Yes, which is BC. CB. Well, I will get it the other way around. Yeah, it makes sense. Yeah, good. Nice. And then Z is at the end, so you don't need anything. Good job. And now what you do is that... So what I do real quick is I also need to store the index. Or no, I don't need to store the index. Or yeah, I need to store the index. Or how would I do the indexing? I can just use a DQ for that. Same thing, but like, how would I use it is, should I do it to D vector? I do it to D vector. Yeah, I should probably do it to D vector. Can I do it like more easily? Yeah, you can just do that more easy. It's just, it's a vector of what is a pair? A pair in but what is a multiset? Yeah, multi-set is what you need to use. So we use a multi-set. Multi-set. You have the character and you have int. So we have a multi-set of like characters and ints. Oh. You just have a vector, so you have a pair. A pair can have everything. So the games. I smoke with you. You taught me to pass it by. And now you just have stores pairs. So you have stores vector, pair. So it's a pair of char index and char. And then more. And then you push back. And you're like in place. In place, and then you'll have I and acetyl. I don't like this. vector of int, and then I would want a vector of char. So and then I would need a vector. So it just works. I have to do this. Yeah, I need to push back this. No. Have n minus 1. It's a vector, it should have a size. Just call it sub. It's too much. Sub. No. Sub. And I cannot get the size of sub. What? Sub dot size. I cannot get sub dot size. And this is a pair. I got the first thing. But second. It's the second, this one. Yeah, my pairs. I just need to do no, I just need this one, and so on. I just need to do that thing. I just need to... Yes, I need for C, I need to use Z. I smoke with you. So I need 2 pointers. So I need the one in the beginning and the one in the back, and I need that each place, I need to place it at S. I need to check, right? So how do I do that? Well, I have a pairs, so I start from int and I equals 0, I less than n over 2, right? Or equal. It's always going to be itself. No, it should go till n. No, it should go till n over 2. And I have and j is equal to 0. is less than equal. So the other part works. Okay, nice. So you can just do this, right? And you can do, you can swap. No, I'm joking. So you have S at I, so you just swap the things. So you swap. First value with a second value. I can just say I can just say string s, so I can say string s at I can say string s, so string, so I can say s at I, s at, so I need to get the things, the pairs. So I have auto, which is a pair, auto, and then I have a pair int of char. Auto, I get sub size, second, no, I get subsequence at I, so first X, Y, but I don't need this at all, I don't know what I'm doing. So I need at sub at I dot first, there's dot first, so at this dot first, as I'm doing, so at this index, at the index of this guy, so at the index of this guy, so at the index of this guy, and then when I'm doing, oh my god, and then I'm doing the index of j, and here you put sub at j dot second, sub at I, sub at I second. I think I will remove auto completion. Preferences. Completions. And, so you have this, so you interchange them, and you're done, and you check if, to check if, and the string is sorted in C++. So I just do if is sorted, and then I have all of S. Then I just and see out. And what do I see out? Well, I just see out if it is sorted. Like, I also need to determine what I see. I just see out, yes. I just see out back sub dot size -1 and line. References. No. So yeah, I see out this, else. Out. And I just out. I just out sub. Just out -1. Oh. Second. What did I do wrong here? Segment. Something is wrong. Really? Yeah, I think this part is a problem. Yep. What? Shouldn't even be that. It's not A over 2 sub. Turn me to. What? You're a man leader. You're a man. What? What? Yes, there's two. 6. But it's D and C, right? But there's the 6th one, you're only done with one. What? One, two, three, four, five, six. It is that. Bro, what do you mean? It is that. What? Which is the biggest substring is D and C. You just flip them, so you only have one. Number of steps is just one. But even logically, even logically, like even logically, I'm not. Well, how am I wrong? Yeah, how am I logically wrong? It's 2, 0, it's 3. 0, 0, 0, 0. 3, 0, 0. So this is 2. 1, 2, 3, 4, 5, 6. 8 A's. But that's the biggest substring. D and C is the biggest substring. But you have D and then you have C. So you're saying this is the biggest string. Oh, so it includes those that are the same. See where the problem is. So if it is equal, you push back. and you return this is equal. I think this is the solution. You're the man that world. You're a man either. You're a man it well. Live in the farm. And if they are all the same, if they all are the same, then I can just do this. What? Seven, 8, 9, 10, 11, 12, 13, 14, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24, 25, 26, 27, 28. After the 5. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20, 21, 22, 23, 24, 25, 26, 27, 28. So I had B, D, C, D. Yes, and the biggest is D. It's D, D, C, B. So you have B, C, D, D. D, D. This is a problem, this is not the case. The subsize is not the case, and why is it not the case? Because the D's. It means that is very wrong, that's what it means. Oh, so the last one. Because the last ones won't be flipped. This is what I do. Then I remove. Sub. So I see, so the solution. Yeah, I got it. But the solution. Y sub dot size -1. Sub.pub. Back. What? Yeah, I finished that one real quick. I wanna see the solution though they gave. Dun 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 dun. We'll just go to bathroom.
Last century.
Well, what the main difference is that like I'm back. So the main difference is that validation is like outside the laboratory, It's verification inside laboratory. If requirements are fulfilled, is the design good? Validation is, are you building the right thing? Is this what the user wanted? Is it, and then it's outside the lab when you do things, checking acceptance. Is it accepted outside the lab? So yes, this checks the overall results. Does it work in the big ambient, not only in the lab? Let's check the development phases. Conformance of design models and their specification. Yes, it works with the design models, and are the design models work correctly? And you have conformance of the finished system and the user requirements. Yeah, the whole system, it looks the whole system can be automated. Yes, checking acceptance. Now it can be subjective. You need to check, the user needs to check, is this what they wanted, or so on. Objective can be automated. Yeah, fault model design and implementation faults, problems in the requirements. Yeah, exactly, problems in the requirements. Not needed implementation of yes, needed if the specification is correct. Exactly. Testing processes, software testing, testing processes, software testing. So it has test process, so a process of testing, and it wants us to know how the process of testing is done, right? Because it searches us, it wants us to know what distinguish the different level techniques of testing. We call additional objectives of software test. Summarize the typical software testing process. Summarize the typical software processing test. So I need to tell you how the software testing is done for them. I mean, well, it tells you is first you need to plan and control. Plan. Why do you control? Yeah, so you need to know what do you want for testing, like what is the exit criteria. Like you need to plan first and then control. So planning is the idea how we're gonna approach the test, what you're gonna include in the test, who's gonna do a schedule for analysis, when is this going to happen, when is the test going to end. So you do a planning beforehand, and you look what resources you need, what the oracle, what the environment you need. So you do before this, you plan it, you look at the scope, the risk, the objectives. So monitoring, yeah, that's correctness. So what you do is that you analyze and you plan, and you try to control it in the sense to put in dates, times when things are going to happen, and so on. So you analyze the risk of planning, how much it's going to cost in a sense, well, when are we going to exit, how much testing we're going to do, and so on. And then is distribution. So it's better to early VMV reduces cost. Yeah, it's good the more you check the errors in the beginning, you're gonna get better money usage in case, because it costs so much to fix the errors later. Test strategy. Test-driven development, module and system, JUnit and GUI tester, developers and test engineers, place 90% statement coverage and cover every use case requirement. Test report according to nice. Test plan. Mapping test strategy to the actual test project. Test plan. So creating a test plan. So you have a test plan, so mapping the test strategy to the actual test project, okay. Test objective, test. So yeah, you have a strategy and you have a things you want, but you need to create the plan, because you need to take all the things you want to do and you set it up a plan, then things are gonna happen, what resources, who's gonna do what the test objective, what is the environment, and so on. And then what you need to do is define the test phases. Test phases, length of a phase, exit criteria, measuring quality and testing, okay. What does a test phase include? Yeah, you need the test phases, length of a phase, exit criteria, measuring quality of testing, yes. Test phases is a phase. What is a test phase? That's a good question. Test phases is when you do a phase on when you do the testing. I mean, how hard can you get? And then we have risk-based testing, level of risk and impact. Oh, this is important. Risk-based testing analysis. Impact and probability of failure. If it has big impact and the probability of failure is high, we need to do a lot of testing. If its impact, the probability of failure is 0, it's not going to fail, we don't need to do testing. And then we have a chart, and chart is like a radial chart, you can see it. In this case, it has P1 is like high impact and high probability of failure that it can and should be tested for sure. And then you have high impact and low probability of failure, still it should be tested. P2, high impact should be tested. Yes, this should be tested, this should be tested. And then you have medium impact, can be tested if budget and schedule permits. Yes, P3 is like medium impact. It has failures, but this is not like very necessary. And P4 is low impact, but this part should be tested. This is less important, and this is very important. The impact is very important. And then you need to analyze and design the test. You need to design and analyze the test, and then you need to implement and execute. So first you plan and control what you're gonna do, and then you analyze and design the test. Like we analyze what is good to test, which parts you should steps, how to partition, and so on. And then you need to implement and execute the tests. Yes, and evaluation, exit criteria, and report. And then you evaluate like when should we exit, and then report what we found. And then we close the test. And then you have your test report. They have different kinds of tests. You have unit tests, and unit tests, what do unit tests do? Unit tests, like, the idea of a unit test is that you have like units or like modules and things, and it tests exactly like functions, those methods. It tests exactly the methods, right? And it tests, and then it looks at the source code and it tests specific units of the code. Integration test is when you have a lot of parts and then you integrate them together, and you test how those are integrated together, how the networking, the containers, database, how files are connected together. Yes, it's like a much bigger effort. Yeah, you have testing levels. You have unit, so you have the unit, you have the integration, then you have a whole system. So you have the units first, and then how they integrate with each other, then how the whole system works with each other, and then you have the acceptance test. Is it accepted with your environment? Teach me, dude. And alpha and beta. Oh, just the test levels. Look, the unit model is like the functions and the small classes, and then integration is how these classes and functions like work together, like a part of them. For example, how databases, and you create, for example, an application for databases, how all those parts work together. And then you have the system. The system is the whole things, like every possible things that you can test in laboratory, right? In sense, when you say laboratory, it means what I can test in a in my program immediately in my IDE. And then so you have acceptance test, but acceptance test is like those tests that that is like, this is acceptance test does the validation, not the verification, not the, wait, I think I messed it up, but oh my god, yeah, validation, I was right. Verification is in the lab and validation is outside. To validate what you've done is right. So the idea is I don't know, the alpha acceptance is it validated from outside? For example, this is done outside. I do the software, but now I need to go to the stakeholders or the users and explain it to them. Is this what you wanted? And does they accept it? Okay, this is what we wanted. That's acceptance test. It's not like really testing that we knew, like unit module integration system is like very precise testing and so on. Acceptance test is like, was this what you wanted? Like you ask, literally you ask the stakeholders, this is what you wanted. And alpha and beta testing is literally when you get different users to test your code. That's what it is. Yeah, they're different. Unit is for small methods, and integration is when you integrate this method with each other. Unit is, you have a unit, you have a method, a class, right? It's one thing. Integration is you have several things and they communicate with each other, right? And how those are integrated with each other. That's integration test. And then software testing. And I just explained units, integration, blah blah. And software testing functional is like, I have forgot what regression testing is actually. I don't remember what regression testing is. Till now I was just doing like code forces exercises, but never mind. But the point is, I was coding till now. So I've not done a lot, but majority is good. But the idea is this is that functional is that it has the function. So for example, the user says, when I press this button, I wanna do this, right? That's functional. And then like, what are functional and non-functional things in a software? I mean, this will explain what are functional and non-functional things in oh my god, in software. Functional and non-functional requirements are two categories at top. Okay, functional requirements are literally functions, like literally a function can describe a specific behavior or a function in a system. Literally like, I want you, when I do this, when I praise this, I want this to happen. That's like functional requirement. Non-functional requirement define the role, characteristics, or qualities the same must have, but don't specify specific behavior. So yes. So non-functional is like, I want it to be secure, right? But that's not like a literal function. Like it's not a button I press and it becomes secure, right? It's a general thing. That's what non-functional means. Is that it's not described by a user, it's not described by an interaction or behavior. Literally UML says it's behavior. So it's not described by an interaction with a program, but it's just a overall property of the system. For example, quality of a code. I mean, you see, it can be functional at the bottom, but what is its quality? That's a non-functional thing. So there is a distinction between functional is like done, button, press. Is button, when I press, I want to become red. That's the function it has. Non-functional is like properties that you assign to the system, like how usable it is, how easy it is to refactor, how safe it is, and so on. That's non-functional. Test types, so like the test types. So for example, non-functional test types are very close with validation, or in other sense are very close with like the acceptance test. Because do I accept this program? This is very good. I mean, you have functions, right? So when I press the button, that's what the thing that happens. That function is happens. So it's good. You can test it with unit, integration, and the system. But then there is acceptance test. How quality that is? How quality is the source code? It's like properties. Not you can implement it. Like the requirements are implemented here. The requirements are implemented exactly. But is it accepted? Like is it a good test? Like there are other properties that are not literally described in the requirements. In a sense, like those properties are like are they safe, and that's what non-functional is. Test types. Non-functional test types is literally this acceptance test and alpha and beta and so on. But no, even alpha and beta is very functional because users come in and press buttons, but it's both of them. But they also tell you like I like this much, I didn't like it. It was good color, it wasn't good color. So alpha and beta is both. Alpha and beta testing is when two users come in. I forgot exactly what it means, but what is alpha and beta testing? Yeah, alpha testing is the first place of testing, so it is conducted by internal developing teams in an organization, and beta is when you release it in the world. For example, you remember Fortnite had beta testing because it released it to a world, and alpha testing is when developers have it. That's the difference. I find alpha is developers, beta is when you release it to the world. And then regression test types. What are regression test types? What are regression test types? Ah, that's regression testing. Now I remember. Yeah, regression testing is, for example, you do a class, you have tested the class before, right? But you have changed something else, so you need to, I mean, you have not changed the class specifically, but you have changed, for example, some other part that requires that class, but you still need to recheck the class. That's a regression. You need to regress back on the tests. That's why it's called test type is called regression, because in a sense you're going back on the test to look. It's not progression, it's regression, because you need to go back and look to test again the other things. And then we have techniques. Test design techniques, no idea. Okay, test types make sense. What kind of type? Functional, non-functional, regression, testing levels, you know, unit, integration system, blah blah blah. System and acceptance, and then alpha beta. And then test processes, how do you do it? You first plan it, the test. After you plan, you analyze what you need to write, and then after you analyze and designed it, then you need to implement it and execute it, and then you need to tell the results. You need to end it in a thing, and then you tell the results. And after you do that, what you need to do is to have a after test, when you talk what could have been better and blah blah blah. They have a specific name. Test closure, they call it after that. But I need the test design techniques. Okay, experience based, no idea. So ad hoc testing, exploratory testing, freedom and responsibility of tester, test design, execution and interpretation in parallel. Experience based, ad hoc testing, I don't know. Exploratory testing, freedom and responsibility of test. Experience based? I mean, experience based is like I just go into my program and just look if it works right. Okay, not do any unit tests and everything. So that's what exploratory testing is. And then you have or ad hoc testing, specification based, and that's like the good one we learn, like unit tests and so on, because you have the specification and then you need to look at the specification, and then after you look at the specification, you need to derive regions, like to find the partitions and so on. Exactly, it says here equivalence partition, boundary values, use cases, user stories. So you take the specification, you see like how the sets are divided and how everything is partitioned into things, and then you check those sets that you're created, you check it inside, does it work your code nice, and the boundaries, does it work nice, when you interact with each others. And then you have decision tables, combinatorial testing, right? You have advanced technique. This is specific. This is like every day what we do when we implement something. Like we don't write unit tests. We just do it easily. Like we just go to program. When I type my function, it outputs something good, nice, and it looks pretty good. That's what it does. And specification based is exactly what we have learned most of the time, like unit testing, integration testing, software testing, all of those. And then structure based are the one we learned like with coverage, like how much is coverage, what kind of coverage, this is the thing. Exactly, white box. This is like a black box, because you have no idea about it's called black box because you have no idea about the software you're doing. You just have a specification, but you've never seen the code, and according to the specification you derive the test. And you have a white box where you have a code, and then you see how much, and you do the test. When you have the code and you do like unit tests we've done, like we had the code and we tested the code we had, and then how much coverage we have and so on. And then this advanced technique, data flow testing and so on. Basic techniques, control flow coverage, advanced techniques, no idea. Those are flow testing, they never learned this. And we have fault base, never. Fault based testing, I've never heard this. Fault based testing.
Okay, experience based, yeah, specification based, yeah, structure based makes sense. It's fault based, I've never heard it though.
So what is fault based testing? So you have error guessing, previous or typical faults. Nice. Mutation testing. Okay. Mutating the code, evaluating test, mutating the task, mutating the test. Fault, I don't understand this. Fault-based testing, also known as fault injection testing, is a software testing technique where intentional faults, errors, or defects are introduced into the system. Okay, so you have your code, and you think it's right, but you intentionally put some errors, and you see how well the system can, and you see how well the system can detect. What? You can just write in chat, bro. Like I have to pull all of this. Fault based is that you are testing based on a faulty behavior. Yeah, testing based on the faulty behavior. Yes, you know that you put some bad behavior in your program. I think this explains everything. So you see, yes, exactly. The thing you said is exactly. Fault based is what you're testing based on a faulty behavior. So the idea is that you have your code and it is like faulty, right? And the idea is that this code is faulty, but how does your system behave when it has some faults? How good does your system manage those faults? Like how good are your exceptions or so on? That's the idea of fault-based testing. Your base when you have faults, how good is in catching errors? Literally, it makes so much sense. Because you're like, how good are your exception handling, literally. So let's introduce errors. Let's suppose you have your class already, but you have implemented no exception. When someone else uses it, it's like, it cannot catch things. No, I've not done this. We have a sample exam, I guess. Central Asian student. What a name. I mean, I think I will later after I finish the slides because there's like millions of slides. I have 7 left. I mean, a lot more left, but it's just so many slides and things like mutation testing. Yeah, there's the thing, you mutate something and you see what happens. I understand fault-based testing what it is. And then you have probabilistic, it makes sense. Probabilistic is just like try to find the error and how good it is, and it's just probabilistic methods. Easy. It shouldn't be that hard. It's like you have like a curve, right? You have like, I don't know. Can I write? I can write, I guess, because I have my tablet. Let's go. I know, I'm just explaining to myself, but right. So you have like let's say you have things and you see how, let's say you have like you get the distribution and you get like, okay, you say a user usually for age, right? So age is like 0 age, 90 age, and you say, okay, it usually happens more inside here, so the age is usually here, so let's test it more here. So let's test it more between, I don't know, 20 or like 18, 15 to like 60 age. Let's test it more here, the program, because here is going to be used most, and the edge cases we don't test it at once because we don't care a lot. That's what probabilistic testing is, literally. So you're just testing like the region where the probability of happening is like higher. And then you have testing, the life cycle, you have V model, agile models, blah blah blah. Yeah, V model, in each thing you test, in each phase you test. Yeah, I can explain it here very good, I guess, because like you have a requirements, right? And then you do all the implementation things and you have system validation. because you need to validate what you've done. Is this the right thing? Is this what your stakeholders want? Is this what the user wanted, right? So, and then you have a system specification. So this is what you analyze the requirement. You have a specification, what you need to do exactly, and then you verify if you have done the specification right. That's a system specification. And here you have a design, and when you design things, is how they're integrated with each other. This design, you have things, components, things, and you integrate them with each other. So that's in the system integration test. It's not that hard. Then you have module design, and modules are like the smallest units. You have unit tests. Model verification and unit tests is the same thing. But you see, validation is with the outside world, and verification like in the lab or in the development phase, or whatever you want to call it. Reviews, simulation, blah blah blah, fault tree. Oh, I don't know ETA or BD. I've never heard of them. I mean, they just put so many things in here. I'm like, SIE, HIL, PIL, like what are these? Real world accepted. Monitoring and fault tolerance. Test design. I mean, there is such a good lecture. MIT has such a good lecture explaining the V model. It's like insane. I mean, these are they just added this coding guidelines, static analysis, modeling, checking, rapid prototyping. It's just like nothing. Code coverage. It's like, so you write code in here and you have static analysis for the code, and you have a code coverage, how much you're covered, and then you have designs, how are they with each others. So you have models here, you have the models interact with each other. So you like a prototype, you need to check them. I don't know, just like this, they just added them and never explained it either way, so it doesn't matter. I think that like if you really want to go deeper, I just found code forces. I just found like such a good lecture, verification, and then you have a MIT one. This one was so good. Like he explained it so good. Let me. Ah, you can't even hear him.
How many repetitions will you do? And then product verification enabling products, which would be test software, test.
Why is this so much greater? Like, oh my god.
But are enabling of the verification process. You then essentially go through this process, and what are the outputs? The product verification results.
Why doesn't it sound?
Test protocols, things like this.
Yeah, this guy explains it so well. I mean, you can just listen to him and like.
So let me just give you a quick example here from my own experience about this verified end product. One of the things on the Swiss F-18 program that we did is not just buy airplanes and equipment, but also models of the
He explains like verification and validation so well in here.
of the structure. And these models were very expensive. Like some of these models were millions of dollars. And so I got a phone call. I was a liaison engineer.
This guy is speaking so low.
This is crazy. You know, how can we be charged millions of dollars for this particular set of models? And I said, yeah, that seems pretty expensive. So I'm going to go negotiate this. And so I started negotiating. And I guess either I'm a bad negotiator or it was really clear why these were so expensive. The reason these models were so expensive because they were on the right side, not on the left side. So every one of these models that we were purchasing had been verified using actual physical tests.
Who is writing?
Under the low conditions to produce a.
Central Asian. Thank you for subscribing. I guess I don't know.
So the model had been very carefully calibrated and tuned against.
Let me see. I mean, testing. I don't know. It says.
Okay, so with that in mind, let's talk about testing itself, what kind of testing there are. And so testing is one of the 4 methods of verification, and it's the one that we often spend the most money on. So this is from the handbook, section 5.3. This is basically an alphabetic list of the kind of.
He just explains it like everything in detail, and probably all the things he explains is just there, because when I see it, like when I look at MIT lectures, and when I look right here, you have the best explanation of validation and like validation and verification. Like it's so much better than a lecture, like 10 times he explains it. Like it makes sense when he explains it. In a lecture it doesn't make any sense when he explains it, but never mind, we move on. Agile testing, this is easy. Easy and not easy at the same time because he just complicates it. Agile testing quadrants. Customer facing, technology facing, quantity, product, quality engineering. Like what? I never got this. Agile testing quadrants. Let's see. Does MIT Legends have like some good videos, because they are just better at explaining things. I don't know this quadrant at all. Not this AI guy. Oh, I hate this AI. Oh my god, I can't. Sorry. Oh, this guy should be good. But we listen to them all. Why is this so low? Oh. Okay, functional test acceptances. What? You have technology facing, you have unit tests for programming, and for product you have performance tests, load tests. Oh, this is like integration tests because you have a product, a system, and this is like the support for programming. Let's make it bigger. This is like right here, this part, like blue here. If you can see my mouse probably. This blue part right here is that it is like supporting the coding phase, like the units, the components, the tests, and how they integrate with each other. This product is the whole system I test, and it's the technology facing, and they have a whole system testing for exploratory test, usability test. You see, this is like validation, this part right here. The upper part is validation, and the lower part is verification. This is done like at the IDEs, the developers, and this is like, how does a business validation, how does it work for the business? Is it the right thing we created? Is it the thing they wanted? So you see, exploratory test, usability, how it's used by the user. That validation has to do with user. It's not like for validation test. And you have, or in other sense, acceptance test, the same thing. The in programming is called acceptance test, and then functional test, how does it function with the user, and then acceptance test, is it accepted by the user, and then you have even more like general product, you have like exploratory tests and usability tests. It's for, yeah, humans, formal, technical, blah, 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 and then here you have, yeah, I mean, just, oh, on round one, let's see, this is a sample task, text, can I just do this because it's like too big, this, yep, so you have like a sample, please, where are you going, my friend, here, I'm tired, bro, okay, am I, what, stop. Oh my god. Stop. Okay. This is so weird. Okay, control 1, this is sample text. Oh, bro, why do I press the mouse? No, that's insane. Okay, this is a sample text that you can edit. Bro, that's so... You made me wait for all this. No, this guy explains for that. You see, it even has like a better...
Hi, I'm Doug Stewart, and today I'm going to talk about testing in Agile. Some work has been done recently in development of Agile testing quadrants that relate to different types of tests that are possible in an Agile environment. It's based on the book by Lisa Crispin and some of the work prior to that by Brian Merrick. This work organizes our thoughts because our tendency in Agile is to test the story test, and that requires an artificial approach that's not terribly efficient in ensuring that we get testing for all of our constraints and compliance and other types of rules that we may have, although it is extremely effective at testing our basic pieces of functionality. So with this approach, it gives us a more balanced view of testing and allows us to provide a product with a higher quality. So first, let's look at a quick view of our requirements, because this is how we're capturing information about the system. And these are the specifications of what our system is supposed to be doing. So let's take a quick look at our requirements. The requirements are what we're going to test against. So before we look at how we're going to test, let's look at what we're going to test. So in Agile, we typically have some sort of hierarchy of information. So we have things around an investment theme, which may have a number of epics. There may be features involved as a
tomorrow. I think I'm gonna do it tomorrow because I need to finish. Like after I finish the slides, I'm just gonna do. Because then if I do it, I have no idea what I'm doing. So I first want to finish the slides and look where I like fail now.
To discover epics, or they may be discovered from epics, and that's really a personal choice for the organization when they're developing the requirements. Basically, we'll always get down to user stories. So that's the base element that we want to get to, because that's what's really in common between our requirements and the work that we're going to perform. Those user stories then are eventually broken into tasks. So based on this information, user stories may be elaborated by business models and use cases. They may be constrained by usability requirements, performance, and other types of non-functional requirements. And so these relationships are going to happen. All of this is good information that we can use in our testing. So if we start to look at the test matrix, so what is our opportunity for test? We know what we want to test. And it may look
yeah, we can tomorrow. I can do the test. Like, after I finish like the last slides, but I think I'm gonna finish them today, and probably tomorrow I'll do it.
Towards the team, as opposed to focus towards the product, and things that are focused towards the business as opposed to focus towards the technology. And so this gives us.
Yeah, no problem, no problem.
And so where they intersect, the team.
I mean, this is easy. I think unit test, performance. Yeah, it makes sense. Performance security. I don't need to wear this. Just I don't know. This is easy. Like they explain it. Unit testing, code derived, static analysis. Is just like. This is like verification, and then you have verification. code server, not performance testing, like verification as a whole system, privacy, stress testing, exactly. It's like system side, stress testing. This is like functional testing, and then code coverage is like non-functional testing in the whole system in a sense. And then you have customer facing, you have runtime tools, functional testing, acceptance test, right? And this is like what quality engineering thing. How well it's engineered, and then you have how well is every day the product used by the users, take home, explanatory testing, yeah. And this was all easy. What is pretty easy? Hey, bye bye, good night. I don't know if you're here, but good night. Why do you have... what? Why do you have all the same logos? Huh? Okay. I don't know. Why do they have this image? It's so interesting. Okay. Test design techniques. I mean, I think you understood this, not that hard. A quadrant like this one. It's like you have technology, so you have a code literally, and you have engineering the code. And it's like, what is the smallest engineering part you can have? It's like the unit test, the code coverage, static analysis, like it's those things you do at the code. And here you have like a product thing, so how it is, but you have technology facing the product. So how does the product, like non-functional testing, the stress things, how it's secure, how like overall performance of a product. It's like literally how the small things are done, like how the engineering small things are done. It's literally how the whole overall product, but this is like technology facing, the technology side. And then you have a customer facing, and you're like how the customer sees it, like how does it want it. And you have the engineering side, it's like acceptance test, does he accept it, is it functional, how its runtime is. And then you have literally the product. You have literally like the product and customer facing, and you have like how usable it is. Like you have a, literally like have a usable user product, customer face out customer user product is like, is it ready for the word, beta testing, literally explanatory test, like beta testing, the user will use it. I mean, you can derive this, I think, or like if you look at this and then like they probably will give you like, put unit testing, and it'll be like on unit testing in this quadrant, and you'll be like, put performance testing, like performance testing at this quadrant, and you're like, beta testing is like, here, facing and product, and probably that's going to be the test. But like you can derive them pretty easy, I think. And then you have summarize the challenges of test design. Easy. So apply basic specification based testing design techniques. I've done the cards for this, like I have the Anki cards, I've learned this before, like I have testing here already. Design techniques and overview. I have it already. But for the previous one, what were the conditions? So the conditions were recall the definition of objective software. So what is the definition of objective software? So testing, the definition of testing is that you have software and you want to see how the software performs in a specific environment, or it was the right thing built. That's testing. And then, and was it built the right way? Was the right thing built, and was it built the right way? And summarize the typical software testing process. You say, was the right thing built because did you apply the requirements, right? Was that what the requirements wanted? And then that's verification. And then you want validation. It's like, was it built the right way? So was it the code? You can build the code and specify a requirement, but is it good code? Is like a good code written, or is it like free of, I mean, safe, and refactoring is good and it's easy to do and so on. So this like validation things. That's what it's saying. And then obviously, yeah, the definition of testing is like you do test in a software to find out to see if the right thing was built, and to see if it was built the right way, and to see if there are faults in your program. to catch them earlier so you get less damage in the money in the long run. And the objective is to make sure that you get as less errors and you have a good product, but you also, in a sense, save a lot of time and effort, because the later you catch errors, the harder it is to fix them. So it is so much more easier if you just test them beforehand. That's why the V model is, in a sense, good for like critical systems and so on. And summarize a typical software testing process. So, I mean, I told you the process is first you plan the thing, what you're gonna code, right? You plan like when, how, what environment, how much money, and so on. And then after you plan, you analyze and design. So you analyze, okay, I need to test this, I need to partition like this, I need to design it, to design the test, and then I need to implement, because you design it like in an Excel table, but you need to implement them. And you have an implementation, I need to test them, so implementation, testing, and then to run them, to execute them. So implementation, execution, easy. And then you just have the result at the end. You end the test. So when do you end the test? And you have a result you pull out, and at the end you have like a test. It has a name, I still forget it. It has like a test go back or recall, like it is closure. So you close it in the sense what we could have done better in testing, blah blah blah. It's like at the end you talk like a conclusion, what can be better. And then you have summarized typical software testing process, blah blah blah, easy. Distinguish between different levels of techniques of testing. Different levels. The levels of testing I just told is like unit, and then you have integration, blah blah blah. You have a system, validation or acceptance test, and then you have beta and alpha testing, but that's okay, no problem. And then techniques of testing. Yeah, you have functional, and then you have functional things, non-functional things, and you have regression. When you look back, you test if you've changed something, you also need to test again the tests you've changed, the things you've changed. That's the techniques of testing. Yeah, that's all they want. And then you have this part, testing and test development. Learning outputs. At the end of the lecture, the students are expected to be able to summarize the challenges of a test. Summarize the challenges of a test. Okay, so we need to tell at the end of the lecture what kind of challenges we will face when we do some tests. Okay, no problem. And then apply basic specification-based testing. So, and then distinguish between the two types of testing, the specification-based and the structure-based. What are the other ones? Well, specification-based, structure-based, and then explanatory testing, you just do things. And it was fault-based testing and the probabilistic methods. So, your favorite topics of the subjects, your testing and test development. The typical development workflow, you have unit test, system test, E2E test, blah blah blah. This are, you see the unit tests and static analysis and coding is when the developer does it, and then when you integrate it with the system, blah blah blah, you have a system test at the continuous integration server when you integrate with the whole system. And E2T tests the same thing, it tests the whole thing. And basic design principles. Why is the test design important? More than act of testing, the act of designing tests is one of the biggest bug prevents known. Is the system well designed? Can it be tested? Wearing the glasses of a tester and blah blah blah. Testing is good. A different mindset. Happy path, system under test, use case, quality, blah blah blah. Not important. You have all these paths that can have different minds. What he's trying to say with this slide is that you can test for different things. You can test how much your code is covered. You can test only the good path, so user only clicks the button and doesn't click outside your program, or doesn't click like a weird button he finds somewhere. So that's like the happy path is only he does the good thing, the user. And then you have unhappy path. You have exceptions or errors, like those cases that are very weird, that the user does something weird, and then you have valid input, invalid input, blah blah blah, use cases. Not hard. Basic concepts of testing. Reminder: specification, requirement, test cases, test execution, verdicts. System under test. Test case: a set of inputs, implementation, condition, and expected results developed for a specific purpose. Oh, we learned that. We had this before. This is just a revision. A system under test. Not hard. So you have the requirements, specification, you have a test case, test execution, and you have a verdict at the end. It's not hard. So you have test case, you have test suite. Test suite is test case is one test, you have input and outputs, and then you have suite and many test cases, and the oracle is the truth. What you accept, this is the truth, this is what it should be, right? That's the truth, that's what the oracle is. And they have, what a typical question it will be is like, what are the verdicts of a test? And you should be like, pass means that the test passed, good. Fail means that the test failed, which implies that the program was wrong, the program don't have bug. And then error means that the test was an error, which implies that there is like the test doesn't work. And not the test doesn't work, the test might be wrong. And then inconclusive, which is like, we don't know. So we can just ask ChatGPT real quick, but I think that's like the right answer, pretty sure. But can we have some music? Bro, I've been steaming for like 10 hours already, this is insane. Oh, this one is actually good. Bum, bum, bum. Oh. This is what I usually listen when I code. Na, 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 na. This is... Yeah, this is like this it's also good, but I like this the most. It's like I love this the most than all the others. Dun, dun, dun. Dark Side, let's go. I have it in my Spotify. Oh, I have a good playlist in my Spotify. It's called Dark Side. If you really wanna like listen to funk, it's called Dark Side. My PC is dying, probably 12 hours of streaming. No, Dark Side, funk. Yeah, this one. Dun 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 dun. Bangers, all the bangers. Okay, what did ChatGPT say? Pass. A test case had been successful, blah, blah, blah. Fail. A test case had been executed, but the actual result does not match expected results. Yes. Error. An expected event error occurred. An exception occurred, or something like that. Inconclusive. A test case could be invalid or validated due to some unforeseen circumstances or issues. Yes, exactly what I said. Error is like when an exception enters. A fail is where the input and output doesn't match with what you wanted. Task to solve. Reminder. It's just the same thing repeated, but okay. So you have text selection, oracle problem, exit criteria. Because when do you exit? When to stop testing? When is it's good enough? And then test selection, what is the oracle? What is the truth? Like what do you compare it? What is the complete truth? Test design technique. Select test cases based on text objectives. Yeah, specification based and structure based. The specification based is like you don't look at the code, you just look at the specification, like user does this, user does that, and you're like, okay, during the specification when I press this button this should happen. But you don't know the code, right? And the specification based, so the code is a black box, you have no idea what's inside. And then you have structure based, where you have a white box and you know what the code is and you test the code, you test every line of code. It's like structure testing. Yeah, coverage matrix. What percentage of testable items have been tested? Specification based, requirement, functionality, statement, decision, yes. Coverage criteria. This is how much is coverage from Y completely. This is not fault coverage. Okay, what does it mean by fault? This is, I think this he mentioned that. Coverage, this is not fault coverage. Fault is an error, right? This is not how much error is coverage. Exactly, this is how much the code is covered, not how much the error. That makes, yes. You can cover the like, one line of code can have many errors. You can cover the line of code, but you still can have error, but you just cover the line. Doesn't matter. How to use coverage metrics. Evaluation, measure, selection, goal. Evaluate quality of existing tests. What? Ah, so there are two ways so you get a coverage matrix is that you get the matrix, the coverage matrix tells you how much, that is the coverage matrix, exactly how much percent of the things are covered. So covering matrix, I tell you how much of the code is covered, how is it covered, blah blah blah. And matrix because it's just a measure of something. So that's a coverage matrix, and you have this matrix of how much is covered, and then what do? You either make your tests better, or you select your goal, you select your test. This is what we did. We either made our tests better and made more quality tests, right? Or you do more tests. One of them. So design tests you satisfy criteria, or you make a test better till you satisfy criteria. I mean, why do they use this here? How to use coverage matrix? You analyze the coverage and then you apply other things. Specification based testing. Yep, the design techniques. Goal, select test, cases based on text objectives, specification based. Structure based, yeah, specification based. You have equivalent partitioning, boundary analysis, use case, use story, combinatorial methods, decision tables. I think we don't do the last two ones though. I have no idea how they look either. I need to eat a quick. I know, I need something. I'll just do some, I don't know. Yeah, like bananas. Yeah, I'll just eat something like this. I can cook something, but now I just wanna learn. I can cook. I think I need to cook because I'm not. Nah, we move on. I think I need to cook though because I'm dying of hunger. Like. Dude, you can go, I think. I'm dying of what? Bro, I'm dying of hunger right now. I'm literally not eating. I'm only eating 2 eggs all day, and I'm eating some other things like fruits. I've eaten a lot of fruits all day. But I think I'm gonna cook something. Or no. I don't know, I just... I'm dying of social engineering. Bro, don't worry, we got this. Yep, same. Yeah, when I do tests, I eat like a lot of other things outside. Like, look at this. Look at this. I cook some. Nah, I cook. Like in the morning I cook because when I have like when I have like some free time, I cook. But usually I just buy this kind of things and I just eat them. Or just cook meat. I just buy meat and cook it real quick. Like it's so fast. It's so much faster. Either way, it doesn't matter.
Let me eat. Oh my god. Well, boundary analysis is easy, equivalence partitioning is easy.
Let me pull out this. Oh, look at these bangers. Look at these bangers. Some of this and some of this bangers.
Well, it is what it is.
If I had some meat, I would have cooked it, but like I cooked the whole everything I have. Like I need to go tomorrow to a supermarket and buy things. But I really like eating those small things because like I can eat and also read them, right? So it's like lol. Hi bro, how could you do that for 10 hours? I can, bro. That's all I do. Like I eat sometimes, look at this. No, it's not exactly 10 hours though, because sometimes I take breaks, like you can see I take like 20 minutes break, a lot of 20 minutes break. And sometimes I just do like coding, I don't know, I'm bored with this and I just code. I should also start buying takeaways, like, no I can't, because takeaway takes so much time for me if I just like go here real quick. I just eat protein bar, nah, I eat meat bro, you should try meat. Bangers. Meat is a banger. Like meat keeps you so much, like if you eat meat in the morning, like you're like for 6-7 hours you're good. If you eat something like small, you like 2 or 1 hour, so I don't like it. But if you eat meat a lot, it's like, oh my god, extreme power. Bum 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 bangers. How could you do that for 10 hours? I don't know, probably at 12, because you can only stream for 12 hours, so I'm just gonna finish it at 12. Because I'm done. I'm not very tired though, I'm used to this. So I just never mind me. Let's go, we need to learn. Specification based testing, easy. Partitioning, you just have sets, if I'm not mistaken. Yeah, input and output equivalence classes. Data that are expected to cover the same files. Cover the same part of a program. Goal, each equivalence class is represented by one test input. Selected data. So the idea is that, let's suppose you have a function and takes in integers. Right, this is the idea of equivalence partition. Let's suppose you have a function, so let me write it. Although I'm eating, my keyboard is gonna become so nasty anyway. Let's go down here. Yeah, we'll continue tomorrow. I continue every day till I finish this exams. It'll take my whole life, but okay. You have like an integer. You have an int, and you have an integer here. And the idea is that I don't know what does it return, probably integers. But the idea is that you take in integers as a function and you're like, okay, but this function for different integers does different things. Let's suppose, for example, if the integer is greater than 1000, then it does something else. But if it is smaller than 10, then it does something else. And the point of equivalence partitioning is that you partition, for example, because from 10 to 10,000, for example, it does one thing, one way it does the thing. So that's one class. That's how you can partition one way. So let's suppose 10 to 10,000, it does one thing, and then you have from 0 to 10, it does something else, and then from minus in the minus place to minus 10,000. It does probably something else. Like it does different things for the region. So for exactly how they call it is equivalence classes. It does like exactly like it does like different. The function does different things. So the point is that for each of these classes where the function does a different thing, you make a test case. How hard can it be? Yeah, each equivalence classes is represented by one test input. But one more thing that's important here is that you see. Well, you see, data are expected because the same sets cover the same faults that can happen. That's equivalence class. So 10 to 10,000, you have approximately the same faults that can happen. But the point also is that that you also have input, your partition, but also your output is partitioned in a way, right? So maybe you just what they do is that we take for the input, but like the input has a region of output, right? It doesn't matter. This is like a region of output. But maybe also the output is, for example, divided into like regions 1 to 100, and then 1000 to I don't know 800 to 1000. Like let's suppose it's mapped like that. Let's suppose like 10 to is a function that takes 10 to 20. Let's suppose like is a function that takes 10 to 100 to 10 to 100, or 10 to 500, it takes it here to 10 to 100, and it takes 500 to 1000, it takes it to 800 to 1000. And so you have like different output classes, like equivalence output classes. So maybe like how do you put them together and blah blah. But I think it's important about the output. They really care about the input, the partition of an input, because in a sense input is what's important. Output you can like kind of know what the output is going to be, because that's what it is. Like that's how you test. You know the output. You have your oracle. Highly context dependent. Yes. Depends on the skills and experience of the tester. Exactly. Like actually not it's like an extremely hard thing though, because you don't exactly know how the function looks, and you don't know what the function, how exactly it partitions the input, and you're like, okay, how do I do that? So if you exactly know what approximately this function do, for example, every AI has an activation function, and if you know approximately what the activation function is, you approximately can know the, because this is like specification based. Right, so you don't like really know how the function looks. It's a black box, you have no idea, but you know that the specification kind of divides things like that. I think they have like a good example. You can, yeah, they have an example here. We can just take the example. Selecting equivalence classes. Selection using heuristics. Initially valid and invalid partitions. Next, refine partition. Oh, so your heuristic is a way to do it. That's what a heuristic. I can't say that's what heuristics means. Heuristics. It's heuristics. Okay. Yeah, what heuristics means is that it's just a way to do a partitioning. So they're saying a way to do it is that the function has invalid and invalid outputs. So you just remove the invalid outputs and you just get the valid inputs for the function. And you're like, okay, nice. That's like a partition you can do, which is a very dumb partition, but it works in a sense. And then what you do is that you take this valid partition, you separate it further. You have even more smaller refinements, how they like to call them, but who cares? Like, you get the point. Typical heuristics. You have an interval from 1 to 1000, you have a minimum, maximum, blah blah blah. So let's say you have a minimum to, a function takes this value as a minimum, and maximum it can be 1000. This is literally what I said, I think. And then you test for minimum for between those two values, and for maximum greater than those value, for example. Or if you have a set, you define invalid elements that, for example, this is a function and it takes in colors, literally was saying colors, and you're taking some colors, right? That's what specification says, because we don't know what the function is. This is like specification based, so you read the specification and then you test it. But the idea is that, let's suppose the function takes some set, and you're like, set has invalid output, so you have invalid colors that it can take, or invalid colors, so you only look at the valid colors and you test those. Like, in a sense, it seems very easy, but they just like to put words in that and make it like, oh my god. But yeah, I just feel like pretty dumb. I mean, in practice, like, so much easier to do it in a sense, because it's just like, I just do this. And you're not really thinking about this kind of partition. You can't just do it by, I don't know, just happen. Custom, month, February. It's okay. A specified format is a string when you have something like weird. For example, is it the right password? How would you partition the classes, input classes of the right password? You partition invalid passwords and valid passwords. But the problem is that the space of invalid passwords that you can input is like very big. So how do you make it smaller? How do you take, with less elements, how you present that kind of big thing? So that's like refine the partition. That's not like refinement. It's like I just take like specific passwords which can test for everything in a sense, because I cannot input every password in the world. Deriving test cases from equivalence classes. Combining equivalence classes of several inputs. Yep, if you have color here and then you have another integer, what do you do now? Well, this has some classes. This is the best color. Okay, oh my god, I am typing with my hand because I'm eating. You have a color in here. Color. You have a color and you have an integer, and the point is that integer has several classes, for example, like this, partition classes, and you have a color, and it also has several partition classes. So what do? You take for each partition class, you use each of them. So you take invalid colors and integers from inside this region, for example. You take valid colors and integers inside this region, and then you take invalid colors and integers inside this region, and you take invalid colors and integers inside this region. So you test everything with each other. Because what can really happen is that maybe you put invalid colors and you have an invalid region here, and somehow it cancels each other inside the function. That's what it really is, because like that's why you test everything, because it can cancel each other. And I mean canceling, for example, it checks if integer is valid, it doesn't even work with colors, right? So it's... yeah, it avoids their effects cancelling each other. Then combining them systematically is a... So first you define invalid for each input, for each set of input you define the equivalency classes, and you just do their combinations and so on. So let's do this. I can't see class partitioning. Okay, equivalences class partition. Let's do this. The loan application shall be denied if the requested amount is larger than 1 million. So let me eat this real quick, and you can read that and try to do the exercise. I'm just looking how much more we have. Yeah, it's not hard. Probably sound very weird. Wait, where are we? Sorry, this is the exercise. You can try to do it, and I'll do it. Why did I... here. If I eat this, you have time. I think I'm just gonna finish the test though, for sure. The slides. I think I covered it from 12D to 7 and then 8. This is the last one, like from here to all of this. But I did a lot of coding today. Like I did a bit of like competitive programming, like 2 hours and not 2 hours. Like, yeah, approximately 2 hours or more, a bit more, like 3 hours and so. But I did cover like this interaction diagrams, I think. Yep, interaction diagrams. Then I covered I also covered a bit of C, like half of it, like the states and so on. Yeah, what do they mean? Blah blah blah. I covered this a bit. Then I covered 11, which is structural modeling. Also, structures. This was a big one. And I covered 10. Like general models, like well, all this UML generally. Small things. This was easy. And what is modeling? What how to do modeling? And then I did the test designs. That's general, and then this is like more specific how to do this literally tells you how to do the specification based testing and the structure based testing. Now I'm here. Where am I? I'm here. They use forints, oh my god. Use euros. I don't know, these people are in. I'm done with this. I need to wash. I'll just wash my hands. War is important. Oh my god. Let's move on. Did he send? I think he will send me a BME. What university does this guy, man. He's trying. No, let me send him. Good job, bro. Okay, so let's how you do partitioning of this. Let's see, so you have a loan application shall be defined that the requested amount is larger than 1 million. So you have loan application, okay, so you have a loan application, and then you have like as input, I mean I am not writing the functions because I don't know it, but as input you're gonna have requested amount, and you're gonna have like integers, right? So the set your set is like your set is like your set is integers, and you have, if the amount is larger than 1 million, so you have larger than 1 million. So so you have oh, it takes it as, let me put a slash in here real quick. Larger than 1 million. 1 million. Okay, one. You know what? I'm not gonna write 1 million. I'm gonna 10 to the 6 because I can. Greater than 10 to the 6, then you. And customer is a student. So you also have customer in here. Customer. So you have, and customer is a student. So you have customer. So how you define customer? Customer has customer. The classes can be student, and the classes, whatever classes can have, like other. For the moment, it's just other because we don't know. But house and then requested amount can just be divided into, like, it's very, I think, into this category is greater than this. Then the other category is unless the amount is less than 3 million, so the amount is less than 3, less than this. Oh, and then you, oh, this is very bad, because it is also repaid previous loan. So in a sense, you need to check for every was one of those partitions. And then you're taking for negative values, you're gonna check the loan for negative values. So from -1 to infinity. So that's another partition. So how you partition it? Okay. So the first partition is gonna be from -1, I mean minus infinity. Let me just, I mean, you get the point. Why do I need to write all of this? From minus infinity to, like, this is the first region. So you have like a first region, and then the second region is greater than that. So it's like from 10,000 to like plus infinity. Not good partitioning because ones are like so badly interlapping. So you have this region, so you have the region till here. So you have this region, and then you have the region from this to this, and then you have the region which is smaller than this, so from 0, you have the region from 0 to this, right? You just equivalent partitioning it from 0 to this. These are the regions. This is a negative. Can you have money in the negative side? And then can you have, and you have money from 0 to 10 to the 6, so to 10 million, to 1 million, something else happens. And then the customer can be a student and other, and then you have customer has repaid the previous loan of any kind. Previous loan, and you only have, for bool you always have true. You always have true is true or false. Actually, no matter what, it's a partitioning. So you partition. Like, it's pretty dumb partitioning, but you get the point. Now for each one of those we test. That was the point. You test that repaid, it has repaid. Oh my god, so repaid the previous loan. Doesn't matter. So it is repaid the previous, true, and it is other. Let's suppose, but the requested amount is, for example, between 1 million. I mean, you also need to check like the boundaries like this, right? It is include or it doesn't include, but I don't have like the nerves to write them right now. But you also have, does it include 10 to the 6 or does it not include? But that's the point. You divide it like this, and after you divide it like this, and you check for each scenario. So if it is true and it is a student, and it is the customer has repaid the previous loan, true, right? And the amount is less than 3 million, which implies this too. Right? So you have, oh, this is so bad because you're saying this, you're saying So the loan application should be denied if the requested amount is larger than 1 million. So if it is larger than 1 million and the customer is a student, so you have a student and you're here. So if you're, so this is, I'm gonna do, can I do them? Oh, I cannot do them. But if you have this, if you have student, and if you have this region, and if you have, it doesn't matter. Dun 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 bangers. And the point is that and you have this true and true or false, it doesn't matter. There is one. 31 is true or false, and you have this case. If this is the case, what they're saying, then the customer is a student and it should be denied. This is denied. And then, unless the amount is less than 3 million, and these are two cases in here. Amount has two cases. Like each of one is with each other, right? And then it's saying if you have this, but instead of this, you have true, false, and the customer is a student, and the customer is a student unless the amount is less than 3 million, unless the amount is less than 3 million, which is this. So this is a problem. You see this state? This state is the problem. This is a problem, you see? There is the state. Haha, you can see the problem really quick here. Like, you can see because you are like, you have true and you have false. And you have student and now, and the problem, oh, what I'm saying. The problem is that you have true, student, and this partition, and this partition in here, and you have the true student and this partition in here. So you're saying here it works, and at the same time you're saying here it doesn't work. So requirements are completely cannot happen because you partition it like this. Requirements are pretty wrong. Wrong requirements. That's why it's wrong. And specification based techniques. So you have boundary analysis, you just need to analyze the boundaries. The boundaries is what I talked about. These parts, do you include it, do you not include it? So you just analyze boundary. Examine boundaries of data partition, yes. Focusing on the boundaries of equivalence classes, both input and output partitions, yes. Typical faults to be detected, faulty relation, yes. Because also the output has boundary, you also need to focus on the outputs, on the boundaries of the outputs, like is the output good at those boundaries? It makes sense. Typical faults to be detected, faulty relational operators, conditions in cycles, size of the data structures, and so on and so on. Typical taste data boundaries, yep. And this is very explanatory, the way you take the data. So you take one of the boundary, literally the boundary, and they take both around the boundaries, and then take inside the data and three around the boundaries. So we have now to do a boundary analysis. So let's do a boundary analysis. So the customer has to order at least 3 books. Okay, so the customer has to order at least 3 books to get a discounted price. Okay, so what are the... So we have discount, and we have books. Takes on number of books, int, or just number of books. And then it takes in books, number of books, okay. So boundary is of books, and the boundary is from 1 to 3. And then you have includes from 0, you have from negative books. What happens with negative books? infinity, I'll just write infinity. So you have this boundary. It does not include infinity. This boundary, and then we have from 0 books to 3 books. At least 3. So without including 2. Dun, dun, dun. And then you have from including 0, including -1, and then you have here from 3 to 10 what will happen, and then from 10 to infinity. Discount. Who are these guys? Hello, I guess. I don't know. Oh, why do I need add-ons? Okay, we have free 10, 10 to plus infinity. So what do we do? The customer has to order at least 3 books. So inside this region, to get discounted price. So this the output should be discounted price, and then the output is integer, and they tell discounted price. A customer ordering 10 books is given additional discount. If you order 3 books to get a discounted price, a customer ordering 10 books is given additional discount, so given a bit more discount. Is discounted price plus this discount. I mean, yeah, it's good. What values use for testing? Well, I'm gonna use -1, 0, 2, so values are gonna be -1. I'm gonna use never. I like it more. I don't know, probably I won't want to do this. I don't know, I'm just doing this for fun, like I'm here for no reason, I guess. I'm just studying, I guess, so not to be alone while studying. I can be kind of alone. So the point is, yeah, just for fun. What values to use for testing? Okay, so you use 1 at the boundary, which is -1, and you use 1 inside, for example, minus, I don't know, 1000 I would use, and then from 0, from 0 to 2 I will use the boundary itself, which is 0, and I will use a value inside, -1, -2, and I will use the boundary 3, I will use a value inside like, I know, 4, which is close to boundary, then I would use like 7 or 8, I'll use 8, and I'll use 9, which is close to boundary, and then, I mean, it's like inside, because it's like this one is 8, and then 9 is this one close, so I mean, you can remove some here if you want to, but it doesn't matter, this is not a lot of boundaries. And then I would use, I mean, this is so nice laid out, right? 10, and then I would use like 11, now I would use like, I don't know, I'll do plus 1000, so on. Like these are the boundaries I would use. Specify base techniques, use case, user story, deriving text from use cases. Yeah, happy path, main path, and alternative path, test providing preconditions. Yeah, acceptance text, system test. Like, if you test use cases, that's meaning you're testing for validation, which just means your acceptance test or the system test completely. So yeah, I don't know, you have use cases and you say, okay, let's suppose you have your program, it has buttons, it has some list to type something, and it has another button, it's called press me, and it's like your happy path is that it presses this button. Cause I'm dumb. It's just too. No, you saw nothing, okay? You saw nothing. Yeah, it's tough. It's just, you just make up the boundaries and the thing. Like, you read this and you're like, oh, these are the boundaries, and this is like, okay, I'll put this values on my tests. So I can test these values because these are like the most critical values the program operates around. So that's the point. I mean, user case stories, like I have a program, it has a button. For example, this literally the Obsidian, what we're using is like, what user usually should do is like press X and then exit this thing. But let's suppose he presses, that's the happy path. He does the right thing you're supposed to do. But let's suppose I open this, I don't know, something else. I open this and press X at the same time, or you see, press, oh, so X didn't work, but you get the point because it doesn't allow you to until you press outside. They've taken care of it, but that's probably like not the happy path. It's like user took some alternative path to exit, or like for example, I don't press X at all, but I press Alt F4. They should think what should happen when you press Alt F4. So let's suppose in the background you have some data which is like, let's suppose this is a file, it's not being saved, but it's like locally saved in the RAM but not really put in a hard drive, and then when you save it, you're like, when you press X, they're like, okay, when I press X, I just call the function which takes this and writes it on the disk from a RAM, and okay, we're done. But that's the happy path, and you have like the alternative path. Let's suppose I press Alt F4. What would you do if I press Alt F4, right? Well, they should, and that's like a path is like not really gonna happen. A less happy path. Happy path is a good path, and then the other paths are like what the guy's trying to find bugs, like gamer bugs. That's literally what it is. Mainly higher testing levels. Yes. No, I'm sorry. And this is important actually for the exam, I think. How much time am I left? We have time. We have 40 minutes till it finishes. I think we finish this. I go. Okay, test design techniques. Select test cases based on test objective. Blah blah. Structure-based testing. Easy. You have the code, you have a function. Here I didn't have a function at all. So I didn't even have a function here, but now in a real test, I suppose I have a function, this function. Can I? Oh, yes I can. Can I real quick? Why do you have to do this to me? Flap. And I need to. Yes, exactly. Happy. What? You press Alt F4 and get the new version of Windows? Why is that so funny? I find that really funny though. That's cool. I mean, I use Alt F4 many times. I usually use it, for example, when I want to close my PC, I guess. Okay, nice. So the problem is like, let's suppose I'm here, I can just press like Alt F4 and then I can just press OK, or like enter, I just enter and then I shut down. Or I can like, let's suppose I want to restart, I just press R and I'm at restart and press OK, enter in a sense, and I restart real quick. That's what I use Alt F4 like most of the time. So where are we? Here. So we need to analyze this, I guess. So what is internal structure? In case of a code structure of a code CGF, control flow graph. Yes, this is a control flow graph. So you start this, you read this, and then you have a while loop. So a while loop is, first you do this, and you have an if statement, you even execute this thing, or you have execute this thing, the if statement, and then for both of them you go back to a while, or you check again, do you go back and do the same thing, or do you finish the loop, which is this thing, the last thing. And what are the basic concepts? Yes, we have a statement, we have a block. So a block is made out of statements. Wow, magic, easy, it doesn't matter. But you have a condition, and you have a decision. Okay, this is important actually. Like the condition and decision is like they ask you questions about this. They're pretty annoying about this because they're like, this is a decision branch, but you have like, decision is made out of conditions, and a decision can have many paths, because it can have or in this or that, or it can have else. That's what, like, I don't like them how they state it here, because in the exam, what they did in the exam for me is they said a decision can have more than two outcomes. More than two outcomes. That's what they said. Outcomes. I mean, who cares? Just again. Hello. I don't know. Probably. When do you want? It's 12 o'clock, so 12. I mean 7, 8 in the morning, or I don't know, 9, I guess. Probably, I don't know, 9, probably 9. Around 9 o'clock. For sure, it's probably around 9 o'clock. Because I cannot sleep more than 8 hours, so like from 1 to 7, 8, so probably around 9 o'clock. Maybe, I don't know what you mean by trolling. Well, I don't know, you're I don't know where we are. We're just like testing, like this is like structure-based testing. I don't know where we are. Like I had this question in exam. Does a decision have more than two outcomes? And you're like, okay, so this is a decision, right? You're like, this is a decision, and then you're like, it has two outcomes. It is either true or it is either false. And then he said it's wrong because the way he drew it is he drew a. Wait, I have this. Oh no, I have the what am I doing? You had the. Did I open this? Yeah, I'm joking. Yeah. No, I was trying to explain like unhappy path. Like a happy path is for a user presses X, but an unhappy path is like when a user presses Alt F4. You need to take account of that unhappy path. Unhappy path is things that do not. No, I didn't take the exam. I wanna take the exam. I don't know what they're gonna do. It's like the first time they have this course in university, so it's like I don't even have previous exam. We have a small one. Like no. What I want to say, I was like trying to explain, yeah, what you do is because in UML, the way you think, what you do in UML, you have a decision, and you have like a decision can have many outcomes, and you have a guard. For example, in this region, for example, from 10 to 100, and then you have a region, another region, I don't know, from 100 to 1000, and you have else. This else. So you have, okay, this has many decisions, can have more than two decisions. It can have more than two outcomes. A decision is a decision in UML. No. That is, we have, like, I'll take it tomorrow, the mock exam. And and then I'm like here, but here it only has two outcomes. But actually, a decision in a UML means the whole if and else class. Like this is a decision because what he wanted to say is that how many branches the decision branches. Because if you have how many decision branches, then the story changes. You can have many branches, but the outcomes of the decision can be true and false. But that's probably wrong because they want the branches. Like the whole if else is like a decision. I hate this ping thing. Like it made me make a mistake because the whole thing in a sense is a decision. This is a branch, this is a branch, and you can have many if else, which implies you can have many branches, many outcomes. Basic concept, statement, easy, just a statement, the semicolon, something that ends. A block, many statements put together. A sequence of one or more consecutive executable statements containing no branches or function calls. No branches or function calls. So it's like statements put together, but no branches or function calls. Okay. And then you have a condition. Yep. A logical operators. Logical expression without logical operators. What? Okay. You have a condition, and then you have without logical operators. Yeah. This is without logical operators. See, it's a condition. It doesn't have. These are logical operations, and decision has logical operators, because a condition is like true or false for sure, and a condition has many more outcomes. Like it is true and false, but it has many more branches. That's the distinction between a decision and a condition. One possible outcome. See, one possible outcome of a decision. That's what I mean. discrete math, we have lecture notes and everything. I mean, I think we had, yes, if I can find it, because I removed all my bookmarks. Yep, you have lecture notes. Here you have math. Here. Do you want me to paste it here? Here you have like lecture notes. Here it explains all this is like ITC, this is like number theory and then some algebra. Linear algebra, you see, linear algebra, it's like a very good book. Lecture notes they call it, but like it's a whole book you need to learn, not gonna lie. And then we haven't, for ITC, for like graph theory and things, we had nothing. There is a book I think for graph theory which I don't remember. Graph theory. I wanna find. Yeah, these are just definitions. I wanna find the book. Just, it's not that easy though, you need to concentrate a lot. Where's the computer science? I mean, these are good, but BME, perfect graphs. Perfect graphs. Let's see how much. This probably you can just find professors, you see, and they just have anything like, I don't know, just look at different professors and they have like different things, but this is like Hungarian. I don't like that. You see, you can find the book. No. Well, am I live again? I don't know what happened. Okay, well, I don't have a lot of time left though. Which one is? There is a good one. I think. I mean, they're all good. Just read all of them. Graph theory, just graph theory books. You can just read them. Same thing. Modern graph theory. There is one that I don't remember. There's like a good book about graph theory, but it's okay. Introduction to graph theory. They're all good. They're all the same thing. Same thing, or same thing. Like the same thing explained over and over again, but it's like different point of views explaining the same thing. But that's important. Linear algebra, number theory, graph books, like graph theory, and that's all. That's all. And probably theory and statistics you need to know. That's all. A path. A sequence of events, example, executable statements of a component typically from an entry point to an exit point. A path, a decision. Okay, this I made a mistake. A decision branch is one possible outcome. So these are branches. So the decision is like the whole thing, and those are all the outcomes it can have. And the condition is just true or false. It's just this without the Boolean operators. Statement coverage. Number of statement executed during test. Number of statement coverage, which is bad. Like how many, for example, if the test goes this way, it executes this kind of statements, you're like 80% statement coverage. So that's the problem with statement coverage. You can cover the statements, but you don't cover all the decisions. You can cover like that's interesting. Yeah, if you drew off the graph flow, it's like so much easier to look. For example, this covers every statement, because what you do is like, if this, it's like if this, I don't know, the first one happens somehow, the first one happens, then you go to k equals 1. Okay, if a is greater than 0. You go to k equals to 1 statement, and you start from k equals to 0. That's what is really happening. It's not that hard. And else, what you have is you have m equal to 1 over k, and then you don't have an else at all. Oh yeah, you have an else. Else is m equal to 1 over k. But the problem here is that if k equals to 1, you still go to m equals to 1 over k. So this is like... So either way you're gonna execute it. So it's like this. So this is what this is happening, but the problem is that you don't never care about a is greater than 0 because you never check. But you don't know what happens if a is greater than 0. Well, this happens, but you don't check this branch. Like the branch where a is smaller than or equal to 0, not than this, outside this. You don't check that branch. Yeah, I'll stream a probability too. I'm streaming everything. I did stream probability for a bit. Does not guarantee coverage or empty braces. Yep, this thing, easy. So it's just like this decision is not done. Decision coverage, number of decision outcomes. I mean, you see, like you can have like statement coverage. You can cover every statement, like every statement is done in here, but not every decision is done, because you never check if a is smaller than or equal to 0. So a branch is left out in a sense. So now what do you do? Let's suppose we want decision coverage. So it's number of possible branches. So number of all possible outcomes and the outcomes that have taken. For example, this one is 50% because you have 50% taken of branches. This is a question here. How many outcomes can a decision have? Many. A decision can have many outcomes. What does it mean by considers a decision, isolation, or combinations? Considers every decision, yes. Okay, assessing decision coverage. Each statement is executed at least once. All decision outcomes are covered. Also, which coverage? The statement is easy. How many statements are executed? So you get the code, you say, this is executed, this is executed, this is executed, done. So 100% statement coverage. But if you want to do branch coverage, you're like, oh, a is greater than 0. So you do the partitioning. Okay, so a can be from -infinity to infinity. Okay, so let's I hate writing infinity in here, but the point is yes, you have from -infinity. A can be everything. You don't know. To plus infinity, and the point is that you have from -infinity to plus infinity, and then you have a number of decision outcomes taken. You have a greater than 0, a smaller than 0, so you have from 0 to so a is from 0 without including 0 to plus infinity, and then you have the other one when it is from -infinity to 0. And then it includes at 0. And you can do this, like, good way of doing this. But the point is, you see, here, what do? We cover, so this is the partition, so this was the partition. So, this is a decision, like, this is the decisions that there can be. These are all the decisions there can be. And the problem here, we say a is 5, for example. Input is a. That's the test. A is 5 as input. Say okay, k is equal to 0. K is 5 greater than 0, which implies k equals to 1 and m equals to k. This is also executed. So you can say 100% every statement was executed. What is a statement? Is a thing that doesn't have if things or nothing in there. It only has like a statement which ends. That's what a statement was. It doesn't have like conditional things. A sequence, a statement, yeah, the unit, that's the statement. And the block doesn't have if or something like that. But the point is this. But like so you can say A5 and say, okay, I can only take this test and then I cover every statement. But then you're like, you never covered this part when A is greater than 0, smaller than 0. So what to do 100% decision coverage, you do A is equal to -5 to, for example, or -10, whatever you want. And what you do is that K0 happens, A is minus 10, this doesn't happen at all. So you see it's kind of different, so when this happens there's a different result, then this doesn't happen, it's a different result. and you get a different result at the end. So you see when you cover every decision you're more sure that you've covered everything. And then here you covered the other part, when you this, like when this happens was the first thing and when this doesn't happen was the second branch. And this is just representing with a state control flow diagram, like it's so much easier, or chart. So each statement is executed at least one. Yes, all decision outcomes, decision coverage, each statement is executed for sure. Yes, because that's no, it's like more, it's more broad than the statement. The decision is more broad than the statement. It covers more. It covers the statement plus other things. You see, it covers all the statements, but also the decisions. And each statement is like a decision outcome are covered, also the empty ones. Yes, does not take all combinations of conditions into account. So there is a problem with decision. Does not take all yes, there is a problem with it. There is a problem because oh, it doesn't explain it here. You know what the problem is? The problem is because it doesn't take all conditions into account. So let's suppose you have another thing, and b is greater than 0. This is a decision. This is a condition. The small one is a condition. Like a is smaller than 0, and this whole is a decision, and this is another condition. And the problem is that it doesn't take all conditions into account. I mean, you see, you have all the branches. You have this branch, and you have the branch with this, when this happens, and the branch when this doesn't happen. But you don't need any B input at all. You don't need any B input for that to happen. Like, this is 100%. Let's do else or something. But it makes sense. Even though A is equal to 5, you still cover A is equal to 5, and A is minus 10, so you cover the both cases. And you can say, well, it doesn't cover like all the conditions in here. You can say B is equal to 5, for example, and you're like, okay, it still covers like this thing. It covers all the decisions for sure, because A equals to 5, B equals 5, it covers this, and A equals to minus 10, it covers this. But you don't know what happens if B is smaller than 5. You didn't cover that condition too. So you don't cover every equivalence class in a sense. So that's the point. You don't cover everything. I'm still recording. Oh my god, 20 minutes. So that's the thing. It doesn't cover all conditions, but because you can put like you don't need all of this to cover all the decisions. So in a sense, you can cover all the decisions and still not cover all the conditions. Yeah, this seemed like. Okay, and then masters, I don't know what they do with master. Condition coverage, condition decision coverage. Oh, this is what CDC was. Oh, you remember V model? Where did you see the V model? Here somewhere.
I mean, I can touch it, but I can't.
V model, hello V model. Oh my god, we had the V model somewhere. Yes, you see where it was here, where it was. I don't know. I forgot, but there was some writings. This is none of them. These are never mentioned for some reason. But there was like this kind of things were mentioned somewhere, like this CDC, MCDC. I remember modified condition decision coverage, multiple condition coverage, loop coverage, all depths coverage, all uses coverage. Okay, just master. We don't care. Exercises, structure-based testing. I mean, this is easy. Construct the CFG of the code, design test cases for 100% statement coverage and decision coverage. I mean, it's not that hard. For example, you go here, and then you have a function. So how do you do the function? So you have this, and you have the first statement. The first statement is this. So that's a statement. So you have return 1. Oh, you can't see what I'm doing. So you start the control flow and you have that's the first statement, the return 1. And it is a decision. And it has 2 outcomes. There's a decision with 2 outcomes, so it says a decision. Do they write a decision like that, or am I blind? No, they don't write it like that at all, actually. They just write the statements. I see. You can also see here this decision is not even covered, this one, or all those are not covered. And the point is they just write the return 1. So they just write return -1, and then you have all of this put together. If I can you please? Hello? Yes. And then you have another option is that you go to, you do the, I don't care, I will just write it like this. It's okay. You have int p is equal to 1, this is the other one. But it's both cases you're gonna do that, so you're gonna have the problem is it's this. You do it like this. Because it's, or you can just add a starting phase, but this is how it's done. You have a return 1, return -1. No, this is like one of the options, and then the other options is you have the other option down here. You have int p is equal to 1, and then you have return 1. Either way, you're gonna calculate this. This is the same thing as this. So either way, you're gonna calculate this, right? So what else we have is, why don't they draw arrows though? Yeah, they do draw arrows. Yeah, you need arrows. So you have this thing, and you have this thing, and go here, and then after this, you, if you want to draw it real quick, you have a loop. Oh, you have a loop, so you have p equals to n. But k can be 0, you don't know, right? You may just return p immediately from here. You can just return p. So that's what can happen, because you don't know if you go inside the loop, or you can go here. But this is like a more complicated thing. You need to do all of that. Oh, so you have return p. That's the option, first option, and then the other option is you do. Yeah, it goes to that. I mean, yeah, it just goes there, you can see it. Dude, I thought after return -1 it should go to int p equals 1. Yeah. Oh, but it's return -1. It doesn't go there, it shouldn't go there. Yeah, you're right. Oh my god, I'm dumb sometimes. Never mind, it shouldn't go, it's just done, it exits, it's like, exit. Because it's return, I forgot. It just exits. You're right. This here it just exits. I'm tired. You can see it. And then you have int p is wall. And how do you do the thing? You have int I equals to 0, right? This is another statement. And then you have the check in here, which is I less than k. And then this has two options. This either goes here. Or this goes to p equals to n, and then you have I++, and then we go back to this. No, back to the decision. I don't like to write it like this. I really like to write it with like the decisions. So I really would love if you could, like, this is so much better. I think you have a decision like this, like it's like UML style is so much better. And then you have the exit here, one option. And then the other decision is, and then you have a guard, like this is literally how UML does it. I just like it more. And then you have the guards in here. This is, oh, show a graph. Like this is what you think you do. And then from here you can go to here. But like this is a really weird way to represent it. I don't like this way. I need to do it precisely. I like to use this like literally UML syntax. It's actually pretty good in this case. This is the return 1, which ends. So you do return 1, and you end the program. This is when does this happen? N is less than 0, or k is less than 0. Or k is less than 0. And then you have another guard in here. The other one, else. Just type else. else you just go to. This is so much better. Why do you want to use a diamond shape for a loop? And this is not what I'm doing. This is int p. Also one. The diamond shape? Yeah, you use the diamond shape for a loop. I don't like this, like what they're doing here. Like it's pretty weird. Oh, can I move? Yeah. This thing is what they're doing. Like is pretty weird, because like this is very weird what they do. Like they just. It's pretty weird. Like this is also weird. Like a control flow is like UML1 does it better, I think, in this case. So let me just, like this with diamonds are so much better, it's so much easy. Int p is equal to 1, it's just so much easy because it makes so much sense. And you have a decision in here, you have int I equals to 0. And then you have a decision in here, and the decision is either, so if I is greater than or equal to k, then you return p, return p, and then you end your program. Else, or you can just type else in here, and you can do the guard in here, so you have I is less than k. So you have this graph, I less than k, and then you just have I++ thing, and so you have px equal to n, and then you have I++, and then you can just go to the decision. This is why it's so good, because you go to the decision. Like this makes so much more sense, right? Like here, what is this? Like it's so weird. Like this makes so much more sense. You go to the decision, and then what does it ask us? Construct the CFG of the code. Yes, this makes sense. But if they want us this one, I don't know. This is not good. This is weird. And then here it ends. I don't like this. Nested? Yeah, you just do nested conditional. You do. Yeah, but that's just a big. If you have if, look. If you have if, and inside an if, you have more ifs. Like this is just this and this. This and this is just like a big diamond with more. Let's do an example, maybe more easy. If a is greater than 0 and b is greater than 0, right? And let's do an else here. So how this is an exercise? How does this look? Well, it's very easy. You have a decision is greater than 0. Let's do a statement. This B happens, so B happens in the beginning. B statement happens. Like it's just a decision. No, it's a big decision. That's what I'm trying to say. It's if A is, it's like A is greater than 0, and it's like A is greater than 0 and B is greater than 0, and then the other thing is A is greater than 0 and B is smaller than 0, and here this is the other one, right? So A greater than 0, B greater than 0, A is smaller than 0 and B is smaller than 0, this part right here. Let's call it D. So oh my god, A, B, C, D. So this is D, and this part is just so this A, and then you have, either way you're gonna have B in a sense. Oh, that B is very weird in there, isn't it? But no, it doesn't matter. It just doesn't make it. You can do a big one, or you can just go like B in here, right? A is smaller than A is smaller than 0. You have B in here. And then else you just are outside. You go the other part is F. You do F in here. And then if you're in B in here, you just B. And then you're done because B is B. And then from B you have another decision in here you go into. And then inside this decision you go further, or you can have a big one, what I did previously, if you don't have this bean here. Right, it's, I don't know, it's not matter. Oh. I mean, it's the same thing, you just, you see, you have B in here, you go A greater than 0, you go B, so you go to B, or else you just go outside to F, and when B you have another decision, if B is greater than 0 you just have C, else you just have D. It's not that hard, I don't know. And where the problem is, like, I don't get where the problem is. Dude, how about the code has nested? Yeah, how would we calculate decision code? Ah, I meant the calculation, I already knew how to draw. Oh, okay, how would you calculate the calculation? But yeah, you have a decisions. You see? You have always, this is like a path. And then this decision is not coverage, so this is decision 1, 2, this is another decision, so it's the decision coverage. So to answer your questions exactly is if you have a if something, and then you have else something, and inside you have if something, and you have else something, then you have how many decisions you have? You have 2 for this one, or 3, I don't know, 2. You have 2 for this one, and you have another 2 for each one of them. So you have 2 here. So you have like this, you have 2 here, and then in a sense you have another